Bonjour tout le monde et bienvenue. Est-ce que je ne parle beaucoup le français, mais je comprends presque tout le québécois là. Et for my American friends, that means I really don't speak French, but I understand almost all Québécois, and that is just a quick way of saying. Usually, this event would be in French. We advertised in French, but the purpose of today is really to bring together a lot of people from both sides of the border and from all provinces who've been working on a pretty broad project that has many pieces, and many of the teammates haven't even met each other. So this was my goal today, to have people in the room and have a chance to interact and talk with each other. I wasn't going to record it, but we are going to anyway, so I'll still encourage you all to ask lots of questions, and we have a perfect day in Quebec City, exactly as we all picture this place, and we can all meet up later on at the Winter Carnival if you're going to be in town. So, my name is Eli Gould. I have been leading a project that started fairly quietly and seems to have grown a lot. It's a real privilege to lead tool building efforts that are meant to be free, open source, and publicly used, and I think everybody on my team shares that same sort of passion when we've been able to gather really great talent around us. And as problem solvers, looking at how difficult it is to manage timber and biosourced materials in the modern digital environment, we realized there were huge gaps. So what we're going to see here today are really a chain of people who I've asked each with their own expertise to help close some of the gaps that we found as we embarked on this project. The main thing, though, I think, is that we have such a mix of people in the room here. I do a lot of work in the U.S. Educating architects, and I think that this whole project is kind of an extension of that. And because I think that way, I will be using this as training material. So I've created a short presentation that gives the sort of the background on what different tools are, because BIM is such a jargon-filled world. I think some of our friends here have really done great to reduce the amount of jargon, but everybody who uses BIM likes to use acronyms. They like to fill the whole space with a lot of technical terminology, and that's really hard for everybody to understand. So I think my first task here today, and why I'm going to speak for a little while here, is to do basically an architectural training mini course, a nano credit on what the tools are, so we understand when we get the experts up here why they are building something in sequence. And I think it's really important to start with the fact that we're a promotional trade association agency. We get some funding from industry and public sector, and that's why we have to stay at the early phase. It's where we have the most impact on changing things, but it's also really where we have to stay because we can't go downstream. We're talking about people who are exporting into the U.S. market. There's really responsible professionals downstream, or trying to be responsible downstream, EORs, life cycle analysts, engineers. Many of them are here today, and we can't do their job. When we can't do the manufacturer's job, we can't choose the software they're going to use. But what we can do is stay upstream and provide really good content that flows down to all those experts. So that's why we stay there. And I want to also really get a baseline going here is other industries, specifically steel and concrete, have already done a really good job at the things we're trying to do. So the architect may not have design intent to optimize for another material, but their tools are built by the other industries. So we need to be there, we need to give other options, and we need to follow some of the playbooks. So I will talk about some advanced stuff, but then we're going to return to some pretty basic groundwork that we have to do as an industry to get our standards, our data, and our dimensionality clearer to the architects. And I think many of us today feel like the way to do that, especially in really complex questions like carbon, is with collective open source software principles. The data is just too big for any one of us. The topics are too broad. But some of the youngest people here who come from open source software and data science are actually showing us that, well, we actually have a way to do that. This is what version control is called. This is what data management, this is how people co-author complex calculations, and you can look and see who's contributed to the code, so to speak. So that's why we feel like we need to bring that mentality right into the BIM environment. But to do that first, we really need to focus or get everybody on the same page with what are the design technology tools themselves and where we work. So I'm going to go fairly quickly through this, but the presentation is available. We have some functionality steps, we have actual program teams, and then we have actual people in the room here. So we started at the bottom of the page with a Revit plugin. We're going to be talking about that, but we quickly realized that the Revit user is not always a decision maker, and we actually needed to go further upstream. So functionally, we really feel like even early, before the model is started, people who are creating a comparative scenario and want to know what it would be like to switch to biosourced or timber materials need that information. And then the second step, configuring and visualizing that data, is a huge challenge. We decided right then that on the program level, we're going to call in data from external sources, people who are working on this every day. And then somebody needs to create a report on that data. And we were surprised to find, we thought it would be, let's show people how much better the wood is. That's not always the case. Sometimes it's let's show our colleague why one small change can really help us. So we're listening to the professionals, and I would say the users that we're most excited about right now are the sustainability advocates within architecture firms who are impacting what their firm is doing. And then the idea is that at the end of all that, you start the model with great content. And we realize in the US market, we don't have the luxury of building 2 BIM models to make a comparison. Most of the professionals I work with are like, Eli, we have like 15 minutes to advocate the wood option, and it's on our time, and it's right now, 15 minutes from now. Can you help us? So that's sort of where we have to stay focused. But so all the people in the back row here are all people who've worked on different pieces of this. I want to thank them all and give them a chance to speak. So I'm going to move forward quickly. My learning objectives are to cover what is BIM, what's a basic level of practice, what's not BIM, how much model sharing is there really, and what are these new ways to deliver content into the BIM environment? What are object-based catalogs? What is the object itself, a dynamic object? How are parametric tools different than a catalog, so we can see them? And then how is web access changing what's traditionally been a desktop environment? So we'll just touch on plugins, configurators, and collaboration platforms, and that will put us in good shape to see one of our tool builders later on show about essentially the online multiplayer example of what BIM collaboration can be. So also Nicolas Catellier did a really great video on our Offsite Wood YouTube channel called What is BIM? We wanted to call it BIM for Dummies, but we heard that the For Dummies franchise sues people who do that. So, many of these are concepts and slides that he covers in more detail there. So in the life before CAD or AutoCAD, you can see what the architects were doing, and I threw in the modern equivalent of that is actually the fact that SketchUp is still such a great modeling tool that you will still meet many architects, offices, small firms who might be using 2D AutoCAD and somebody is using SketchUp to model something quickly. So I want to introduce the idea that quick modeling is really needed. Architects need to understand massing and forming and how things connect, and sometimes the BIM environment is just too heavy for that. But it always makes me sad to see SketchUp, because I know that the person doing the exploring in that modeling tool is not really conveying that to the rest of the team. It sort of dies on the vine there with that. It's hard to. So we are excited about other modeling tools that are agile enough to let people understand something in 3D, but actually stay in the BIM environment and can convey that information. And I think many would agree with me that today Rhino is probably the most present, and I'm glad to see people using Rhino, knowing there's a bunch of ways to bridge that. but most architects really are at a level of practice. At least we're probably at, I don't know, I mean, I've heard 85% of the BIM environment in North America is actually Revit based. I don't know if that's exactly true, but they certainly have grown to a monopoly position. And most architects are using them at least to what's called level 2. So they're linking data in a model, and in this case, we have a door that's being stretched and moved in 3D. The plans are changing at the same time, and there's a door schedule or a list of doors that has the data from that door on it. And so that's at least where most architects are running. Many are doing a lot more. Some are not even doing that much, so it's a good middle of the market for us to understand. It's also important to know that material data lives within the Revit environment, not just on the drawing level, but material databases are sort of external. They often run below what the architect is messing with, but they're present if a new material happens suddenly, like it actually has in our industry. I mean, mass timber is not a material, or CLT specifically didn't really exist. Well, there's a new type of material, and how that gets into firms, gets loaded, and gets stored is really a key part of our work today. My own background from the CAD/CAM industry, first coming to Quebec to help with automated timber manufacturing 15 years ago, makes me really well aware that the Europeans have been doing this for a long time, and the architect, in many cases, our challenge is not at the manufacturing level. Manufacturers are interoperating, they're sharing geometry, and there's basically post-processing applications. In the wood industry, I'll loosely say there's basically joinery applications, and there are framing applications. So an incomplete level of detail, a timber that you can model and see in an architecture plan may have a follow-on processing of joinery specialties that go to cutting machines. Likewise, a wall that you draw in a BIM model may go on through a framing application and then go to automated manufacturing of panelized or modular components. So the Europeans not only were really leaders at interoperability, there's an international nonprofit called Building Smart that gives you file formats that do that, and they're sort of more than file formats, but unfortunately they really look and feel like designed by committee. They were started so early. Data handling and programming has changed since then, and they really didn't have an implementation to drive they just kept meeting about it and adding more fields, and those are basically functional geometry, but very, very tough and clunky file formats to work with. But nonetheless, the Europeans do that all the time, and Revit doesn't really want people to use the IFC. They want people to stay in the ecosystem. So part of our role as a nonprofit is to make sure that Revit users know that sometimes you can just transfer out. It's not that hard. Steel industry does it as well, and you can get an IFC file back from a specific trade or manufacturing detail, and it'll be in your model. I'll also just mention that the common language theme among Europeans is why we have multiple machine options for single softwares. So it could have gone the other way. At one point, the automated timber industry started building, every machine had its own language. And the three big softwares in Europe who were responsible for timber design got together and said, this is going to get crazy. We need to have design softwares be design softwares and machine languages be multi-point. And they came up with formats that speak to all the machines, which is why a professional timber designer in Europe can use a piece of software and decide later which of the 30 machines they want to export that data to. So that's where I think we need to stay focused on as we go. Everybody's talking about parametric design, but we need to get a baseline of what that really is. And I'm going to use a few examples here. But a parametric object is essentially a 3D relationship model. There's components that follow each other, and the expert who creates it uses essentially geometric definitions, associated data, and rules, and then the non-expert user can say, I want my timber grid to be 30 by 30, and all of the pieces of that advanced calculation, the calculations can run in the background, and the model can be actually adjusted automatically by a non-expert user. A lot of us have been really excited about this, but we're not sure whose role that is. It's a really tricky one, and I've asked the industry who I know has these tools on their desktop to bring it, and they're like, no way. The engineer record needs to do this. We don't want to give people our expertise. We don't want our competitors to steal our expertise. That's not our job. You can't have it. Keep it on the desktop. Don't tell anybody about it. So I was really glad when an engineering firm known for timber, some young tool builders there talked their older team into sharing essentially a timber grid design tool that would run a scenario. It's not perfect. It's not optimized for different fibers, but it'll educate a web user about how different grids might affect sizing and material use. And I know some of the tool builders on this, and I was glad that the EOR actually stepped up and said, okay, we can share this with a long disclaimer and with calculations running in the background. And the tools running in the background of this are, once again, we have Rhino as a modeling program, but we also have graphical scripting. So basically, the relationships are defined in many cases by architects who don't write code but can link pieces. And the graphical scripting software is Grasshopper, and then within the Revit environment, that's called Dynamo. The exciting thing for those of us from the industry is now Rhino can run inside of CAD/CAM. So now you have a case in which you can create scripts without writing code. You can automatically run a modeling application in a manufacturing software, and that can go out to a machine. And that's going to change a lot of what's possible. And it actually could be a really big deal if that power is used for good. We will see. As I look ahead, I usually try and keep an eye on what's going on in Switzerland. It's always like a view into the future a little bit. And so there's some students there doing amazing stuff with basically going directly from joinery logic to irregular timber to robots, and already showing us how utilization and optimization could be done here. All of these are driving what's now, it's a new acronym. It's actually, acronyms happen so fast in the BIM environment that a new acronym is already old. DFMA is a design for manufacture and assembly, and it basically implies a lot of industry expertise being baked into tools that allow architects to design with the core logic of the manufacturers already built in. There's already a new design for manufacture and disassembly, which I think is an awesome notion. I sort of get reminded, like when my daughter says things to me like, "Dad, that is so 2021." So it's sort of embarrassing to come all the way back to this and say, well, first thing we need to show you is our catalogs and our families. And are catalogs obsolete is the question. I don't think so. The steel industry doesn't think so. The masonry industry doesn't think so. Concrete and rebar don't think so. So you have to be there in the BIM environment with catalogs to even get started with anything more advanced. And so we have really tried to work on that. And though the other industries and their trade associations have done a great job for a long time, and even before BIM was really active. So those standards need to be written. We need to decide how to get them into BIM catalogs, and we need to build consensus, and then we need to be there. So interestingly, the way that BIM software can actually, through its API, be accessed by the web and go out to the web is a really, it's a changing space in terms of how information gets shared. And the most basic and first responders were sort of, well, there should be an online marketplace where you can download BIM objects. So that's obviously an extension of the CAD library world. I think that our Revit experts in the room would often don't think that leads to really great content. The marketplace fills up. People think we're just going to put a bunch of company stuff out there. I found pretty quickly that the good BIM managers at firms would say, we don't touch company content. We don't let our workstations connect to a site like BIM object that's going to have stuff that makes our whole models crash. We have rigorous standards about what our architects use. Our content needs to not mess up our model, and it's not appropriate in many cases for us to be seeing a company name, a website, or a phone number on a toilet. That's not how we roll. So that was made really clear. And yet there are also other models in which you can go online and configure your own wall, for instance. And BIMsmith is an example of that I think is actually doing a legitimately good job at something that we probably couldn't afford to build. So if we want to have a wall builder, we would probably partner with a service like BIMsmith that has a way to aggregate many layers of materials, generate a custom piece of content for you, and let you download it with a consistent sort of quality and ante. So that's a good thing to know about. We're also watching the export from BIM models and how, I was talking about file transfers before, and that's definitely something we hope to see less of. Sending a file to somebody else and hoping they can translate it, and then when you update it, and we got to do that all again and scrub out stuff is a real pain. And we really love to see trends in which you can have essentially calculation as a cloud service. So you may stay in your detailed model, and it knows what to scrub and publish to the web, so you can run something like, in this case, from Insight, it's an energy modeling calculation. Now, it's not a perfect energy modeling calculation. It may not be predicting exactly what the building will do, but if it's giving you insight about how you can make the building better while you're still working with not a lot of downtime, that's great. And I think for the timber industry, who's still really not using a lot of model-based estimates, it would be really nice if people could download our content, build a model, and then publish something to us that they knew they weren't sending us their secret Revit template, they weren't jeopardizing their own firm-wide toolkit, but they could just send us a scrub-down estimate, and we weren't trying to figure out how many toilets there were in the building, but we could look at the actual core shell and make comments, manage issues, get an estimate, make a proposal. That's all in the near future, so we got to stay linked to that. And then when we embarked on building a plugin, I didn't really realize at the start, but we are actually running a web-based content delivery service that comes into Revit. So our plugin is it's essentially like a mobile app that opens within Revit, and we have a back channel, basically like a corporate intranet, where our multiple companies can each have somebody charged with their content, and they can upload it themselves. So that's why we didn't want to have a bunch of stale content out there, and especially as we realize the standards are yet to be written, can we do this in such a way that we can get consensus from the industry, get a standard description of some things that aren't well described, and then update all the content at once? The answer is yes. Or the answer is yes, we can technically update all the content. The answer is probably no, we can't get consensus from the whole industry on what to do with that. But nonetheless, I think that the trade association is here to build infrastructure. We're not here to make final decisions. And the infrastructure in content delivery is essentially a plugin that sits on the App Store and lets us publish different things to it. And we had to organize our manufacturers not in the way they think of themselves, but as the Revit or architectural shopper thinks about them. So we had to organize loadable components, which are mass timber columns and beams. Floor system families are more of a native Revit idea, and it's a horizontal assembly, so that fit pretty well with the mass timber industry. Didn't really want everybody to be doing walls and shafts right away. Let's just start with slabs, and it turns out that was hard enough. Enclosure systems are also handled differently, so those are really a huge number of fabricators, essentially, not necessarily charts of products. And then we have aspirations to really have modular and volumetric builders be able to be described and able to teach architects in the same way. Each of these represents an industry that needs to be negotiated with, and a limitation within Revit, and a delivery model. So it's a long, slow process. It's expensive, and I'm not even totally convinced that the plug-in is always the right tool. As we realize that there's so much more that goes into Revit or BIM in general than just a family. There's textures, there's educational resources, there's templates, there's narratives, instructions on how to use stuff, there's 3D viewer programs, there's surface textures, specifications. So it's really great that we established the plugin and a brand, but it's a lot cheaper and easier for us to really keep throwing content at a website that has a known nonprofit function and a download area that professionals can use. So I'm going to focus on a few of the places we found pain points right away with the industry. The comfort level of the industry versus the capabilities of BIM came out really quickly. My first one was, oh no, Revit does not have enough fields to describe a material like mass timber that has strength in two directions. This is a program that was built on concrete slab on deck. And yet we also have the fact that all the different manufacturers make a different width panel, and that's a driver for design. So I gave a challenge here of a hallway in a building with a slab going in two directions, and could we tell the user how wide the manufacturer makes that panel? So could we span over that? So we used a bunch of different Revit tools here. We're going to hear more from Nikita about what those tools are, but really the industry right away started fighting about, I don't know if I want the architects to be optimizing our slabs. That saves us half of the actual manufacturing. We're not going to give them that. The engineers saying, I don't want anybody cutting up my slab. I need to look at it as a composite first. And so we're really like modest, like, can we get directionality? Can we get some data into this and keep going? And that's taken 2 years. So we're getting there. We also threaten industry comfort levels when we start modeling in detail. And architects do not model all of the joist systems, for instance. In fact, they often don't know about them. And the metal bar joist industry provided a family right away. And architects now know about metal bar joist. They download a Can-Am family. They can see a bar joist happen. It might not be exactly how it's fabricated. They can't maybe do clash detection, but they can see about what size the ducts are going to run through it. They can essentially access the manufacturer's charts with a live object. And before it goes to the engineer, which it always does, it's not stupid. It's something that's like the engineer's like, okay, I can see that there's a bar joist here. I do have to check the sizing. But so I naively thought, well, let's do that for the wood industry. Let's go ahead and do that. So now I'm up against Alpine, MyTech, all the big manufacturers who all have their own proprietary metal plate software design. Luckily, the one on the upper right is a Quebec manufacturer, Triforce. I still don't have permission to share this, by the way, so this will we're still building consensus, but we can model a product like Triforce that has a chart. And we can also we can't do engineering necessarily, but we can get a pretty reliable output of the carbon calculation. And that's how I was able to gather at least enough consensus of everybody to say, guys, we at least want to be able to say how much wood is in that floor, and we don't want the architect to have to model every piece. So can we use carbon as a way to just have a meeting ground, even on the metal plates? I basically told them all, I'm going to try to build scenarios. I'm going to try and get an industry average on wood and metal plates out of each of your softwares, and is it all right if I share that? And we're gaining, actually, which is amazing. The third comfort level pain point is how much data is really going to be in the Revit model. I've been vetoed on this one pretty consistently, but I'm not sure that's actually the industry's first stance seeing their own data out there is, what's my liability? How is our architects really going to be using this data? I don't want to put it out there if it's wrong. I think people who use Revit every day, they know that it's wrong, but they're still using it to understand what the data is around it. And then increasingly in certain fields, I would say daylighting, energy modeling, they are using the model, and they are saying, all right, I can stay right here, and I can figure out my daylighting calculation, or maybe my energy modeling calculation. So we can't stop the fact that it's a tool made for data use, and my stance, at least, is that we should take industry expertise, put the data in there, and talk to the users about how that's being used. And I believe that it's a very limited liability, but that's a consensus building thing. And while we wait to build consensus, I would say we can still educate the market a lot. We can get back to that core activity of these are complex. Architects have a very broad mandate and scope. They need a lot of information. And ultimately, if we're talking about building transparency, we have to show them where we got the data. We have to show them everything we can about how assemblies are done and what's being calculated. These are really smart people who have a lot of commitment and a very short time to action on whatever data we give them. So, and while we continue to build content, for me, one of the really great things has been the beta testing process or the engagement with actual firm-wide experts who are interested in what we're doing has been, to me, one of the most gratifying parts of this whole process, because you meet the people who are building the tools, you realize what they're working with is like a patchwork quilt, but also nobody's ever asked them what they needed. And here we are with a timber industry project asking them what they need, and the answers are awesome. And then there's other ways in which the early beta tester, like we're showing here, they actually switched components 3 or 4 times, and you don't have to start from scratch, because once you have components, they swap in really well. So we had to keep trying on this one. They tried a bunch of different systems. Ultimately, this young technical team was able to use our components, do the tallest all timber building in Boston. They're now like hometown heroes, good friends of ours. They continue to build their Canadian networks for other projects. So I think that process is also really valuable, and it's been a real excellent thing for us to be part of. So that building that was a beta testing building, I just went to the building raising and stood on the 7th floor with the engineering team and looked at what we had done, and that's a really great feeling, and it's happening pretty fast. As we go forward into the carbon calculations, I also want to be really conscious of the fact that we're in Canada with a great group of sustainable manufacturers. We are way ahead of everybody else on our sustainability data. We often have hydropower. Our shops are burning their wood scraps. I mean, if you look at the data, it's kind of like, why don't we show our data more? Because this really is an area in which we could show a lot. Meanwhile, my work in the U.S. is often subject to some big blind spots, and the political borders mean a lot to a lot of people. So one of the things I love about the carbon calculation is it's actually making it more about regional best players and how a producer base and a market can actually be connected. And the political border is not really present in that. And I think it's proving out the fact that you can have manufacturing region like we have here and the Metro North Corridor in the U.S. come together, and you can look at the numbers, and the transport fuel cost is much lower than the fact that you're choosing wood and materials from a sustainable region, aggregating them at a prefab plant, and actually bringing them. And I think in many ways the same can be said for BC and the Northwest and California, and ultimately the same may be possible to say over Southern Yellow Pine. And ultimately, once we have a more mature industry, I think we will return to regional centers, and having this be baked in is going to be awesome. So I'm already plowing ahead, making my life cycle team uncomfortable with, like, how are we going to include biogenic carbon? Once you look at the numbers and you realize the numbers, it is humbling to be part of the wood industry, but I continue to say if we can broaden the framework to what we're really doing here with our building materials, the numbers are going to look a lot better. I underestimated how many stakeholders are going to be needed there. So I already have the information I need. I went to forestry school. I stood in a hole, many holes, and saw the forest carbon being built by trees. But there's no life cycle methodology incorporating forest soil yet. We're not even there yet. But we have to really admit that when I'm talking about carbon in the top middle, we're talking about the carbon in the building. And we're not talking about avoided carbon on the right-hand side from other industries. We're not even really talking about biogenic carbon or the carbon that's being fixed by the biological activities of the forest. Because it's plain humbling to realize how many stakeholders are involved in that calculation. And again, I sort of naively said, all right, well, we're going to need really good forestry data. And that's only half of it. We really need when the end-of-life story is told and it's in the market and the management and landfill practices of the market are being told, that's part of the number. So when I'm faced with these huge numbers of stakeholders, I tend to turn to young experts and say, can you guys build a dashboard and we can have everybody come to the dashboard and put their number in? And so that the rest of that story is going to be told by my teammates here. But ultimately where we're trying to go is the industry, the architectural industry has really understood operational carbon pretty well for a long time, and they understand the energy use intensity of their building. Can we quickly give them a lot more data so that they're actually looking at the carbon use intensity of their building? I think so. I think most of us in the room think so, but we're here today to try and cover the steps that might be needed to connect that chain. I hope I've set the table for a bunch of linked presentations coming from here, but I'm happy to take any questions. So the next speaker that I'm going to let go in, we're going to go kind of sequentially the way that the data that the workflows that we're going to talk about. I'd like to follow a little bit of a sequence, and I'm going to pretend for a moment that there's a Revit model that's just getting started and an architect who's trying to figure out what they can learn from nonprofit tools built by the wood industry, and I'm going to let a Revit expert from your own city here lead that conversations. So Nicolas Catellier has been great to work with and has helped us from the start of this, so I'll let him come up. And I think you're going to do a live demo as well? Awesome.
All right, I am Nicolas Catellier. I'm a local. I live here in Quebec City. I'm originally from Saint-Georges, so an hour south from here. But I've been living in Quebec City for a while now. I am an architect. I studied here in Université Laval and also in Montreal, for which I lived in a few years. I'm an architect and a BIM specialist. I worked for 10 years at a firm called Atelier 21 Architects. And when I started working there, I already had a small Revit experience for about a year, and they hired me with the promise that I would help them with their BIM transition, go from AutoCAD to BIM, and which was a reason to convince them to hire me at first, but then BIM became a passion for me. Turned out that I liked it a lot. So I worked there, and while I helped this firm transition to Revit and to BIM, I started creating documentation, creating tutorials, and I've got comments from my teammate that they've enjoyed my content. And I had the idea to start putting it on the web. So that's when the RevitPure.com project started back in 2016, while I was still working as an architect and a BIM manager at my firm. And RevitPure became quite popular. It started as a blog. I started selling premium courses as well. And eventually, almost exactly 2 years ago, actually, I've started on my own at BIM Pure Production, which is my consulting company for BIM. There's a couple of other areas I'm doing as well. I have a weekly show on YouTube called Revit Pure Live, and I've been a speaker at multiple events such as Build and Autodesk University. Yeah, I wanted to speak a little about what Revit Pure is. It's a learning website for Autodesk Revit. And since the launch, since 2016, I've been pretty humbled by the numbers. I had about 2 million unique visitors and 4 million page views. And there's also a YouTube channel where I host weekly shows, including with our very own Eli here. So the goal of this show is to fulfill my own curiosity, actually. I like to bring in various experts in the BIM world and ask them questions and let them present. So it's been really fun, and I've learned a lot from doing that. About BIM Pure, which is my consulting business that I've started 2 years ago, I work with a pretty big variety of clients. So I work with architects, I work with prefab shops, I work with public sector building owners to help them manage their building, and with QWEB also, which I've actually been working for more than 2 years now. It might have been close to 3 years. And one of the specialty of BIM Pure is creating high-quality families. It turned out there's a big demand for that. It started with QWEB, but with other clients as well. Eli already talked about what is BIM. I'm not going to go too deep about that. Maybe I will just quickly share my vision about it. And as Eli mentioned, BIM there's often a lot of acronyms, a lot of jargon, I feel. And it feels to me some people are trying to make it more complicated than it actually is. To me, the importance of BIM, it's really the I about information. It just means that the model, the 3D modeling, in addition to just 3D geometry, you can use this information for scheduling, for automation, coordination, and collaboration, making our work much easier. And a 3D modeling tool such as SketchUp, like Eli mentioned, is not BIM. So to me, that's where I draw the line. SketchUp to me, it can be a great tool to quickly get an idea of a project, but it cannot be organized, automated like you can with Revit or other BIM software. I wanted to talk a little bit about a short history of Revit, because I realize some people are not familiar with it. How many of you didn't know that Revit actually comes from Revise It? Like that was the idea at first. People saying, oh, it's pretty hard to revise drawing. We're going to build this 3D tool, and it's going to be easy to revise the drawings, therefore revise it. And ironically, many people tell me that they find it hard to revise documents in Revit. So I guess it depends on how it's set up. So the first release was in 2000. It was not long after it was acquired by Autodesk in 2002. The Revit 6 release introduced collaboration features. And the first really big project that was made with Revit, and then after that, its popularity started increasing quite a lot, is the Freedom Tower in New York City in 2004, 2005. And a fun piece of information is, of course, BIM is not the same as Revit. They're two different things. One is a process, the other one is a software. But the term BIM, apparently, it started in academic, but when Autodesk decided to push Revit with the marketing content, we were looking for some ways to differentiate it from AutoCAD and other existing 3D modeling tool. So they found this term BIM and used it to promote Revit. So before they started doing that, BIM was not really used in the industry at all. So it's pretty interesting to know that actually the term BIM comes from a marketing push from Autodesk in the first place. I wanted to show this chart of the popularity of BIM software along the years. So ArchiCAD in Europe was pretty dominant about 15 years ago, as you can see. And ArchiCAD is the oldest BIM software. It started in 1987, but was not really widely used, consistently used in office settings before early 2000, I would say. But again, you can look at this and see that Revit was not that big back then. ArchiCAD was really dominant. And this is from 2020. You can see that Revit with the Autodesk machine just pushed to complete worldwide domination. All right. Now, in this presentation, I want to talk about a family and multiple BIM content. I want to make sure that you understand what a family is. So a family is a parametric component that is available in a loadable file. In this example, I have a simple door family. And a family can have multiple types at the same time. So in this example, you have doors, one that has different width, different height, and different materials, another one that is made of steel with different dimensions, but they're still from the same family originally. And the Revit family editor is almost like a whole completely different software. So when I talk about family, this is what I'm referring to. Now we're going to talk about giving a bit of context about manufacturers' content. The most popular BIM content website in the world is called BIM Objects. And the content is free for users. So the way these websites work is manufacturers pay money to this website to either share their own families or they will pay them to build them. But this website is often criticized by BIM managers and architects at firms because of the poor quality of the content, or the fact that what this content is made of is not super helpful to architects and other people. And there's often a conflict between what the manufacturers want and what the architect actually need on a model. The manufacturer asks for highly detailed content, but the BIM managers usually want content that is lean and efficient. So there's usually a bit of tension on this side. So now I'm going to roast a Revit family. I always use this example when I want to talk about the poor quality of manufacturing content. So this is called the Rayners Masterline family. So no offense to Rayners. I think it's a Belgian Windows company, so hopefully no one from them is here now. But you can see, like, I made this little GIF of all the parameters included inside of it. So this is a family that is almost impossible to understand. There's like 200 parameters, and it doesn't come with a guide. It's really hard to know what's going on with that. And it's just for a simple family. If you look at the geometry, why is there so many options? Why are there so many parameters? So the issues that we have with this family, the file size. So we have 9.5 megabytes, which is super heavy for a family. And if you put that in a project, the project is going to get really big. The BIM manager is not going to be happy because everything's going to be slowed down for no good reason. It's just a family that should, typically like a window family, about 1 megabyte should be roughly maximum, maybe a little more, depending on the complexity. But this file size is just unacceptable, and it's going to slow everything down for sure. Then the amount of parameters, you can see that there are 282 parameters inside of this family. That's a lot. So what these manufacturers are trying to do, it's a super family with a bunch of option check boxes, but it's impossible to understand. You look at this and there's no guide. How do you actually use this? I have no ideas. And this is going to slow down the model. So no BIM manager can recommend using this, putting this in the model in good conscience. And funny thing, I've tried to communicate with BIM objects. I ask them, why do you have content like this on your website? And tell me, like, well, they give us money, and that's why we leave it there. So this is just the business model, that there's kind of a conflict between the business model of these content website and what the architects and the BIM managers we actually need in the models. So I've just shown bad examples of what we don't want in models. Now I'm going to be more positive, what we actually want. We want the characteristics of a high-quality BIM content. We want content that is easy to understand. Like, you just look at the family, and it's kind of obvious what you have to do with it. You might need simple instructions, but it's easy to use. And my goal, whenever I create a family, I try to simplify the life of the end user, the person that's going to need it. I want that person to be happy and feel good about having to use this family, not to pull their hair out and start shouting. Ideally, I want a small file size. I don't want the Revit model to get bloated and slow down because of the family. That should never happen. To have the appropriate level of detail, a problem that you see with manufacturers' content is that the families, they're just too detailed. Like, they will model really small elements that shouldn't be modeled in 3D, like screws and nails and things of that nature. So it's important to think about the level of detail to find the right balance between having enough information but keeping the model lean. And it's always possible to link a family to give a website or to link to a PDF file if the user need to find more information about it. So I just roasted one website, the BIM object, but there are actually a few good ones. Eli earlier mentioned BIMsmith. BIMsmith, yeah, I talked to the folks who started this as well. Oh, you cannot see it. Okay, let's try this. Okay, so this is BIMsmith. And yeah, it was started by Revit users that were frustrated with the existing content that was made available. So when you work with them, they have a team that the quality of the content is super important for them. All right. And the other one is called bimcontent.com. And BIM Content, this is an Australian website. So it doesn't have a lot of content for North America, but their philosophy is similar. All former Revit users working in engineering, architecture firms that were frustrated with the kind of content that was available online and decided to create their own. So I think slowly by slowly, people are starting to get it that we need the content we need and what's available. There's a mismatch there. So I think we're getting there. All right, so now I'm going to talk. With that said, I'm going to talk about the work that I did with QWEB and for the Offsite Wood website. So I wanted to start with this first project. This is with our massive timber structure at Unicel, that is a window manufacturer. And this is a timber curtain wall, which was pretty unique. In this case, this is not just a family. Because this is using a curtain wall, which is not technically a family in Revit, which means it's in a Revit project and not in a separate file. But this was super fun to make. And something interesting that you can see here is that this seems super detailed, but it's actually all 2D items that are placed in the families to keep it lean. So the 3D geometry is super simple, but you can switch from one level of details to another. Another project that we've released, I think it was 2021 as well, mass timber components. So we had beam families and post families from Nordic and Art Massive as well. And in addition, something that tends to be underrated is the 2D component. So this is just a 2D component that is used in detailing views. But in Revit, we still do detailing, even though it's BIM. In theory, we try to move away from 2D detailing, but it's still required, right? And there's a lack of high quality 2D detailing components out there. So we've provided some of them. I think this is from a Nordic family that we've made easily stretchable for detailing. All right, and finally, this is fresh off the oven. This is the engineered floor family that was just released like a couple of weeks ago, I think. That is now available on the Offsite Wood website. This has been in the work for quite a while. It took a while to figure out. But this is meant at first for the modular industry. And this is quite an innovative Revit family. I don't think there's a lot of families like that out there, at least not that I've seen publicly. So just to give a little bit of context, when you work in Revit, in theory, you model each element one by one, or at least you can have beam systems for the floors, but like the columns and the beams are placed individually, or you might select the grids on a particularly placed columns of the grid, for example, but the different components are typically independent. So that's the way Revit users typically work. I also wanted to mention that there are some Revit plugins that are usually pretty expensive and more for manufacturers, but then can be used to automate the modeling of wood structure, especially when it comes to walls. I see Isabelle out here who's an expert with one of them, MWF. I've also used AutoCAD, which are based in Eastern Europe as well. Okay, but back to the floor system family, now that I have the context, and we know people typically model each element one by one. So the idea of this family is to use nested components. So when I say nested, it means a family inside of a family. And you can see all the nested components we have here, the subfloor, the columns, the main framing, the joists, and the main frame, which are all placed into a single host family. And one of the innovative features of this family is that you have access to these dimensions, the length, the width, and the floor-to-floor height. So you can easily change from one dimension to the other, and the whole system is going to be adjusted. And something cool that we've placed as well is the ability to have 3D grips in 3D views, so blue arrows like this, so you can easily adjust the family, which makes it just a bit more fun and intuitive to use, and then can be done in addition to manually changing the dimensions. The joist spacing is also automated, which means that in the type properties of this family, you can have a 16 inches joist spacing, or you can switch to 1 feet, and the spacing is going to be done automatically. Another interesting feature is the amount of columns is automatically determined, which means if you have a length of 17 feet, you will see there are 6 columns. If you change the length to 25 feet, you will automatically have 8 of them. And if it's even smaller, you only have 4 columns. And you can swap from one column family to the other. In this case, we have 3.5. In this one, 5 and 1/4. And you can actually create your own columns and enter custom dimensions. And this can also be used, selected in this menu when you work with a family. Another interesting feature is the level of detail. So LOD in Revit stands, in the BIM word, stands for level of development, and there's a tool directly in Revit that is called level of details that is view specific, so each view can have a different level of detail. So in this one on the left, we've set a level of detail to coarse, and in this case, you have a translucent slab, only with the right thickness that appears. In the middle, you have the medium level of detail, and the whole structural system appear. And on the right, we have the fine, so the highest level of detail, and you can see maybe you don't see that much, but there's the metal hangers that appear on the joist families. This family also has automatic structural depth, so I've used the chart provided. So it's a rough estimation. Again, like you still need an engineer to make the calculations, right? But still, we had an estimate. For example, you can see when the width of this family is 10 feet, the structural depth would be 9.5 inches. When it's 16 feet, the structural depth goes to 11 and 7/8, and so on. So the bigger the width, the thicker structural thickness is going to be. And something interesting that we've decided to add, so we didn't want users to have a width of 50 feet, which doesn't make sense with this kind of system, at least without adding additional columns, is that we add a 3D warning. So the way this family is made up, if you go beyond a certain width, the joists disappear. So like the user cannot really use this family anymore. And this 3D text that says a joist length beyond charted value will appear, prompting the user to just adjust the width again to make sure it's in a good spot. The accurate quantity scheduling. So this is a really cool feature. Again, I've talked about the importance of the I in BIM. It's the information. So this is typically in Revit, families are scheduled as such, which means that this is a family that contains everything, so it should be placed in a separate schedule that only contains the whole system. But this specific family use shared nested families. Anyway, this is technical Revit jargon. But what this means is that each nested components can be scheduled individually. So you have, for example, all the columns, even though they're part of the system, they can still be scheduled individually. and you have the volume, the height, the depth, the width, and the quantity for each size, for example. And the same thing for the structural framing. You have the LSL, the LVL beam, and the open web joists, again with the volume, with the width, the depth, the length, and the number of plates of metal hangers if it's required, and again with the total number of elements. And with Revit, you can add any fields, any information you want. You could add cost estimating information in the schedule if you want as well. And also, this gives you access to the Revit API. You could, in theory, run a script, use a plugin to take this information, put it somewhere else. So you can really start harnessing the power of the information. And another feature that is overlooked, I've mentioned how the manufacturer families, they don't have instructions. So we received a family and we don't have no idea how to use it. We have just a bunch of parameters, no idea what's going on. So something that I try to do with every families that I built is a welcome page. So in Revit, there's a feature called the starting view. You can say, when you open Revit, go directly to this view. So the way I like to build my families, I send them to this page over here that contains all the information they need. So everything I've just mentioned to you is included in the starting page. I include screenshots, and I include a text description, and also live schedules. So the users, you could copy and paste the schedule from this container file to your own projects, and everything will follow. And also I can add any internal information, the date, the number of revision, and the version of this file. So yeah, I've got good comments about this from users because I know how confusing it could be for the end users, and especially if they're lazy, if there's a PDF guide somewhere, there's a good chance they're not going to try to find it and read it. But if it's, whenever they open this file, they see it, it's in their face, maybe it'll take a minute to at least have a look at these features to properly understand the family. All right, that's it for me. And I wanted to just quickly do a live demo of, okay. How can I switch the screen like this, maybe? Okay, let's try this. Okay, there you go. So this is the timber curtain wall. But the one I really wanted to show was this one, the engineer Revit floor family. So let me go to 3D view and I'll do a quick demo of the family. So you can see again there are the grips. I can move this family. I move the arrows and you can see if the length goes small enough, the columns will disappear. And what's nice about this is that, so I have this subfloor component. But if I decide, for example, that I don't want to see the floors in this view, I can simply uncheck this category, and this is going to be gone. I can see the rest of the system, even though this is still part of a single family. But the way I've used setup categories, this still can be done. So let's adjust the spacing of this one. I'm going to go to Edit Type. You can see the joist spacing value. Let's switch this to, let's try 2 feet. You can see what happens. I guess the only problems with this is structurally this might not make sense. So again, this is not meant, you still need an engineer in a project if you're using this family, obviously. I can change multiple values, as you can see here. I can swap the column families. Let's switch from 5 1/4 to 3 1/2. So the family works pretty fast, and there's a pretty good performance with it. If it's good to play with the blue arrows, but you might get weird dimensions like this. So it might be better to actually just type in the value if you want to be more precise. And if you want to create a modular project, it's pretty easy to simply copy and paste the families like this. Whoa. One too many. And I can align them one to the other just like this. And then maybe I can copy and paste them for the second floor, put them to level 2. So it seems there's a little gap. I guess this might be a 10 feet floor-to-floor height. So let's switch this to 10 feet. And now it works. I have quickly model a floor system. And if I delete this, yeah, and I could show like right now I'm at the highest level of detail for this view, but I could switch to the medium level of detail, and you can see that the metal hangers disappear, even though they're not precisely modeled in this case. It's more for generic representation. And if I switch to coarse, you will see this translucent slab that just gives an idea of the volume. If I go, let me close this. So yeah, let me show you this. So I have this schedule open. What is nice about it, if I decide to modify the dimensions, you can see that the schedules will be automatically updated with the right values and the right volume and so on. Oh yeah, and you can see the 3D warning now that because of the width is too big, and it tells me to bring it to more reasonable values, just like this. And yeah, I think that's it. Any questions?
So attached to it, you have all the data such as the quantities, I don't know, what about the loads that it can support? You can attach a lot of data based on this simple drawing, exactly?
Yeah. Yes, like when it comes to precise structural information, that a little less my field of expertise, I would say. But let's say that I select this column. Yeah, this one doesn't have that much information, but in theory, you could add parameters, custom parameters that you need for precise calculations if you need, for sure. Yes?
Yeah. I'm wondering about standardized product. Like, is the architect free to do whatever stupid stuff, or the product is very fixed? If you want to use it, this is the standardized dimension, and you cannot defer.
Yeah, well, that's a question that I often have in Revit. Is there a way like to lock the family so that users cannot go beyond certain values? Well, it kind of goes against the idea of Revit that the families are open. In theory, anyone can modify a family and do whatever they want, but we can use certain tricks. So I will say that, for example, the ability to show the 3D text. Well,
You're gonna change, like, I want my 2x4 at 1 inch and 3/4 instead of, and nobody will ever do that.
Mm-hmm.
So you're working for nothing.
Yeah, like in this case, yeah, like I mean, they could change the joist spacing to a value that, let's say 17 inches, which doesn't make much sense. Yeah, in theory, they can do that.
Can you lock it?
You can put some more constraints inside of the family, but it's never going to be that there's no way the architects, like in theory, could enter the family and modify a few stuff. So you still need some trust in the user, and that's why I try to put as much information as I can in the welcome page so the users understand the idea of the family.
Is there a place where the standard stuff are written, that they know that is the standard? If you go outside this, cost increase?
Mm-hmm.
No?
About the cost?
Yeah. No, but that's true. Anyway, if you use a standard window, you have a cost. If you do 1 inch more, the cost is 3 times more.
Yeah, for this one, we don't have cost information. That could be, we could.
We do have the standard joist sizes. So for instance, nobody can use anything but the joists that are at the right size. So the user is given guidance about certain standards on sizing. We don't want to do the engineering. So, and Revit has this idea of a cross-section library that is pretty mature. So an architect knows they can grab a beam and it's the right size beam. They also know they can stretch that to be 1,000 feet long, and their engineer is going to tell them that's stupid, but it's still gonna be the right size beam. So that's where the balance is between. And we chose this family because engineered lumber has norms, and charts. And the companies are big enough that there's nobody who can say, no, stop doing that. So we go ahead and teach what Revit can do with this industry that has norms. We hope that we can bring this awesome type of nested family construction into industries like mass timber, but we have to show what Revit can and can't do first. And Nick's also, the other thing is that I don't think people realize this is not a rookie move. Like what Nick has done here is something that probably would have taken, I don't know, I mean, most people can't do this. It would have taken them a week to do it, and it probably did take you a week on your first try on this, but the second try, you were able to do this. So that's...
Yeah, well, it was having the idea to build something like this in the first place. I wasn't even sure if it was going to work.
Right. So I think it's also interesting, I try to mix up the room because the manufacturers think every Revit user can do this, and they often don't know this is really cool that we have talent who can build stuff. And once we get consensus about what to build and what's helpful, it's actually, sometimes it's a matter of going into the manufacturer and saying, hey guys, this is really cool that your product can be shown this way. But we have to make it clear it's for education, and the architect is really used to starting the model but not ending the model. So that's where we can maybe put people at ease. But thank you, Nick. This is awesome to see this live now. It's pretty cool and it's fresh.
More questions?
So.
Yes.
Yeah, this is amazing. Thank you, Nick. I think it's definitely we're heading in the right direction. I'm just wondering, my question is really linked to the previous question and to what Eli mentioned about the engineering part of this. Is there a way somehow to link this to any engineering design software? Or especially I'm more concerned about the connections design between those different companies. You mentioned the hangars, for example. But do you see potential in the future to
maybe with what kind of software do you think?
Well, there are several like engineering analysis, engineering design softwares out there. No, I'm just thinking more for the future.
Yeah, sure.
Is that something
What?
coming? Is that possible to integrate potentially in the future?
Yeah, we could. I would be curious to try with if you export to IFC, if you try with a few different software, if this is information that is easily can be transferred from one software to the other.
Do we have any wood structure engineers in the room who could help us answer that?
I'll let my partner answer the engineering side, but from the Revit side, the type is governed by the size of the column, right?
Yes.
Everything else is an insist parameter.
In this case, well, the thickness of the system is determined by the width. So the bigger width you have, the thicker it gets. The columns, in this case, we decided to make it like a drop-down menu. You can switch from one to the other. We could also have made the columns the same as structural width, where they grow bigger depending on the need. That could be a follow-up version.
One of the things that we can do in Revit is provide engineering limits that we can build into with different kind of functions or parameters to sort of end up providing a library of, if you're using LVLs, so this is one family, right? You might have to have additional families that break down differently to say, if I have a different condition, I'm going to use something slightly different. And so engineers can speak into that on the front end, and I think you can create lookup tables. I'm not sure
you could, yeah.
with a nested family. But you can sort of create these libraries of, generally, if you have condition X, you want to be using family Y that's preloaded with engineering data that will work. It still needs to be checked individually, but depending on how you organize the families, organize the parameters.
Yeah.
You want to put the engineers out of job?
It's my job. It's my job, so no.
Yeah, I mean, this is the first version. I could definitely see a version where the dimensioning is even more precise, and like this is kind of more roughly, like you stretch the width, and it's proof of concept, in a way, for sure,
The thing we should actually make clear is we built this to calibrate our carbon calculator. We didn't actually think this would be shared. We thought we need to provide a bridge to the material people who will be speaking later from the Revit people. So we thought we just need a quantity that we can defend, And then the architects who saw this were like, that's really cool, I would use that. I think the other thing to make clear is that we have to aim for the middle with Revit, because there's so many users. It gets a lot more complex after that with the number of engineering softwares. So we can't build, the decision of if there was a central engineering software like Revit that 85% of the engineers would use, that would make our path clearer, even if we were going to go towards there. But we're probably really going to stop right here, do a carbon calculation that we can defend with quantities, and talk to the engineers about what they think should be the follow-on if this data was flowing to them from architects more reliably. So.
Eli, I mean, the simplest version is each piece has a unique identifier and a dimension. So any structural engineering software, if you can get that data out of this, you can get it in there. It's just a question of writing something to make it work. So yeah, the answer is yes, you could definitely make it work.
Awesome. Revit also Autodesk has its own structural engineering. Robot or something?
Yeah.
Which nobody seems to have ever used. I've checked.
But I mean, it's an interesting question in terms of has Autodesk seen this, or is there any sense of maybe it could be internal to the ecosystem of Autodesk for later structural analysis?
I mean, we've been talking about it for about 10 years, and it works okay for steel, but not too much else. Right. Yeah.
So this is, I think, a perfect example of why carbon is a common language that we can all meet on. And what most architects say when they try to get to a carbon calculation, especially when they get actually attacked. I mean, we have a Perkins and Will person here who had a well-meaning firm try and say something about a project they did, and they were attacked from all sides about where did you get that number. So when I went into their firm and they said, we just need a defensible quantity to start with, and then we can go from there. It's actually this is the way to link that up, and that's a first step.
Just when I echo what you just said, I think this is a great tool, especially at the conceptual design stage, to inform decision making regarding what type of material to use for the project. So this is really key. I mean, all the engineering and design and connection, this comes later on once you settle on what type of material you're going to be using. So with the cost and for the carbon, this is great.
Cool, thank you so much, Nick. We these are also great questions. We had a sort of a coffee break plan. Oh, we got more questions. Sorry, keep going. Please go.
Thanks for the presentation.
Yeah.
Surely open source feels the way to go. But still, as you were mentioning, there were kind of liability problems, or at least ideas about that were mainly problematic. So how do you feel about letting users or super users get their hands under the hood of what you've worked so far, what you put out there?
You mean with this family that they can edit it? Yeah, to me that's the spirit of Revit. Like, if somebody really takes the time to open this and start messing around with it, I'm pretty happy. It means that they've looked at it and they're trying to understand it, and that means there's more knowledge in the word, more sharing. So it's just positive for me. I mean, I know like people really worry that people are gonna mess the content and it's not gonna work, it's gonna be precise, but I've never really saw that much problem with it. I don't think it's, I'm not very concerned about it. Well, maybe others would think differently.
We will face concerns, but if you look at what we've really done here in terms of like even that chart warning, to me, if one user realizes they were wandering beyond the wood that they wanted to use, and they didn't mean to make the model into a bar joist and concrete deck, but they learned from this family that, oh, my governing spans might need to change now before I get too far down the road. To me, that value is higher than the perceived liability of somebody misusing it. Now I think ultimately we do have a really good IP lawyer involved in the project, and ultimately there will be terms and conditions that will be armor clad, and anybody using this who drives off the edge of their own engineering is going to be liable for it. It's not that's the nice thing about building free tools is you can limit your liability. But having the manufacturers involved, means we really have to build their consensus and their consent to do so. But most of them in this industry have sizers. So this is not a sizer, and you can actually link right to their sizer after this, and they can continue to operate those. So I think the important thing is to not scare people into inaction or not handcuff the architects. And that's where, I think that's where Nick and I are, but that's what we have to do to pull people, and I'm the one who probably gets pulled back at some point, so we'll see.
Thanks for the initiative, taking the time, money, and energy to enable architects to work further and defend wood projects.
Yeah.
So thank you, folks. I'm going to introduce our next speaker here, this is so great to have this kind of engagement. We're going to have a nice long lunch for people to continue all the discussions we're having, and that is the purpose here. But seeing the high-level talent of somebody like Nick is a hard act to follow, but I've been really thrilled how this project has continued to attract talent from all over, and building free software for the timber industry at the same time as the large sort of common enemy we had, Katerra, went under, actually gave a really interesting opportunity. And I knew Mass Timber Consulting as a firm because of Matthias Oberholzer, who's an old friend of mine who had worked for Nordic Structures and for Katerra before founding his own firm with really a binational focus on working with manufacturers. However, I did not know he was going to hire Nikita, who also came over from the Evil Empire and joined us, and had not only deep Revit understanding, but between the two of them, they came up with a way to start using Revit to put structural data into CLT and mass timber families. And like the other things we're talking about, this is a proposal. It's not unanimously well received by manufacturers. It's not clear that the Revit data is useful yet to downstream engineers. But on the way to that, I think these guys they've certainly taught me a ton about how complex the data of something like CLT really is, how inadequate Revit really is to carry that data, or perhaps how adequate it could be if we can build a consensus among the North American players to do so. So this is an engineering firm working on behalf of our industry, also a Revit expert within that firm, able to help us translate. And also, even during the time of this, the scope of this project, for the first time ever, there was a actual binational standard. So this is such a young industry, it's evolving so quickly that when we started this project, there was no way to even have consistent data of CLT at all. But since there's a binational standard called the PRG 320, there now is actually a data framework for CLT. Now the question is, do we dare to bring this into Revit? So once again, my opinion is we do dare, we do try, but this will actually be slower than that. And I thank Nikita for joining us, and also for being brave enough to do this sort of work when we can be facing a veto at any moment. So thanks again.
Perfect. So I'm going to continue on Nicolas's points here. So a lot of talk about Revit again. So the key ideas here I will present today is a brief introduction on Mass Timber Consulting's collaboration with QWEB and what we worked on, which is the Revit limitations related to cross-laminated timber, the development of CLT floor and detail families in Revit, and finally how a similar approach can be applied to GLT and NLT products. So we have been working on these CLT floor families for different North American manufacturers that have nested attributes related to the design and mechanical properties of available CLT products. The goal here is to provide a comprehensive and standardized Canadian mass timber container file that will encourage the use of and facilitate the specification of timber products in architectural in architectural projects. So with software interoperability becoming so dynamic, it can be useful to describe CLT more accurately in Revit so that design professionals can become more familiar with the product and its attributes early on in the design phase and use the information in energy or structural analysis, for example, in other programs if required. So Grasshopper through Rhino inside Revit is a great tool now. Grasshopper has even reached CAD work, and I think everything will kind of mingle together as time goes by. So we do have some challenges, however, which are related mainly to Revit's limitations and the reality that we are part of a young industry where there are no clear North American standards yet. I would like to mention also that the values in the following slides are more like placeholders. So my presentation is focused on the process rather than the numbers for engineering purposes. Currently, it is a challenge to describe the CLT panel accurately in Revit in terms of its physical and thermal properties, mainly because the interface is not appropriate for inputting the required values, which would accurately describe the mechanical properties of the combination of different longitudinal and transversal sections of the CLT. So we can input values for the CLT board, but not the overall value of the CLT panel. And for example, the specified stress grade, there should be a case where you just put that value in and you don't need to calculate too many things, right? Perfect. So we can also see that in the Revit library, there are some limited information about glulam grades in Norway and Poland, but there's really nothing about CLT, and most of the country libraries have just concrete standards, metal and steel. So a similar issue can be encountered when trying to describe thermal properties. So even though the performance of a CLT panel is based on the performance of wood layers within the panel, we are usually interested in the overall value for the CLT product itself. So in Revit, it's easier to define the properties of lumber grades. So for example, a stud, you can easily input all the information. But it's not clear yet which is the best way to input those same properties for CLT. So as you can see, we have the thermal conductivity, density, high specific heat capacity for spruce, but these values are most important, but we have a lot of places where to put the values, and it's kind of hard to organize that in the Revit layout. There's also the additional challenge that values are not always provided for all thermal attributes by the manufacturers. So the end goal, it's like it would be very useful to have an interface that's better fitted to mass timber product description, since these detailed element properties can be exported into energy models to produce more accurate results. And now to the floor families. So here we have Kalesnikov and Structuralam. These would behave as a typical floor family that we call in Revit, and it's used similarly to any slab or floor panel. Nordic Structures, for example, was on board with having the panels detailed to the dimensional coordination level, but they were not on board with their structural data being embedded into the models, as I will explain. So before deployment, we must ensure that Canadian manufacturers with the ANSI APA PRG 320 products agree on the potential of this idea. The surface pattern represents the standard maximum 8-foot panel width to be used as a reference when designing CLT floor slabs. As we've discussed, we've seen it's a challenge, but from an architectural background, I can tell you that it is very useful to know this simple information when designing, and it is usually taken into consideration. The floor families themselves are broken down by floor types that describe each CLT product offered by a manufacturer. The URL linking the general information for a company product is noted in the family type parameters. So it's very useful for the user to go find additional information. And then the floor structure is customizable, and different layers can be added to suit the design. The structural CLT core is distinguished by its material, which is created following each producer's panel availability. So we have the CLT panel as a base, and then we could add on as many materials as we want, so ceiling, floor finish, etc. So in trying to resolve Revit's lack of adaptability to CLT, we created a material library where each material is embedded with design-specific attributes that more accurately describe the panels. Having a unique material for each type of panel provides a way to sort them based on thickness, stress grade, and manufacturer. Again, here we can reference the PRG 320 or the company's technical guide in the material URL, which helps the user guide towards the full product information, and in this case it's design values. So for an engineer it can also be helpful to directly go to those tables. The mark can also be used as a unique identifier for tagging the panels in plans or for sorting them in quantity takeoffs and schedules. So most Canadian manufacturers have similar technical guides where product tables show the design properties of their CLT floor panels. Custom project parameters are created for the materials category, and the identity data describes the type of panel, while the structural analysis values define the mechanical properties of the panel. These values can be easily accessible to engineers and exported into other software for structural design calculations as needed. Here we have an example from Kolesnikov and their design values table, and another one from Structuralam. As you can see, very similar, and the information is somewhat consistent, so it's easy to create or go for a standard in Revit. We can also create schedules with these parameters in Revit, as you can see, with some panel information, and even in Revit, I think they can be used to calculate certain basic things. Moving on, I also spent some time on Revit detail items and looked at the hatch, how we would say it, for a CLT panel. So it's a parametric family of detail items, which is to be used in architectural and structural plans, specifically when designing details and sections. So this one is a bit more specific because we can kind of see the individual lumber pieces. And here we have the ones for Nordic. The cross-section pattern can be chosen to correctly represent the major strength and minor strength directions of the panels, depending on where your detail is cut in plan, so that you have accurate details. And finally, a little video of how this works, if the video will work. No? Okay. Anyways, as you move on, you can move with the cursor your hatch, and it will adjust. The length of it will adjust. And from the panel on the right side, you can choose, for example, for structural lamp, you can just choose the correct thickness of the panel, and your panel would adjust. This is a bit more of detail, but the dimensional lumber family is nested and arrayed to create a layer of lumber board, which is perpendicular to the cut. And then that layer is in turn nested into the final CLT family, where other parameters are used to create the various panel options. Next up, we also looked at GLT panels and applied the same approach. So with the shared parameters linked to each material, we can accurately define the mechanical properties of the panels. And here we have the GLT panels schedules for design properties related to Canada, as well as in the United States previously, since we know there's different structural design strategies. We also wanted to look at the surface pattern size of the GLT floors, which in this case it represents a billet, so a block of glued laminated timber as per manufacturer standards, and the design of those detail items for the cross-sectional patterns are in the works, as well as the Revit families for NLT products. So far, we have created Revit floor families and detail items for 3 North American manufacturers for both Canadian and American users, so metric and imperial. We started to do the same for GLT products while bypassing the limitations of Revit with the project, custom project parameters that can be used to standardize the BIM data gathered from various manufacturers' design tables. The next step is to take this to industry practitioners and designers and gather feedback on how it is used, how it can be improved. And so even know our downstream users looking for such detailed data. Thank you.
That was awesome, Nikita. Thank you. And questions from any U.S. engineers or funding partners here?
The floor panels, that's a Revit system family, right? So that's not an individual 8-foot panel that you array or repeat. It's an area controlled by the profile.
Yes, exactly. Yeah.
Maybe this is just getting ahead of ourselves, but how does that help translate down to kind of the panelization, like the manufacturer of those panels, right? Because every time something turns, it would have to be a separate Revit slab, right? Separate Revit floor. Is there a way to convert that? Are we thinking about that?
Yes, for sure. Thinking about it, it could be expressed through a pattern on the surface. It could be expressed through like this. For now, we just have the 8-foot delineation. There are ways to do it, but as you can see, there's a bit of uncertainty as to how manufacturers want that to be shown. And of course, I've been working on panelization, so for me, it was the first question that I asked: how can someone else know the orientation of the panel or help them decide? And yeah, I think it's important that we find a good way to tell the architect how a panel behaves and where it needs support, etc. But I think we're still thinking about that, and ideas and feedback are welcome.
The other thing we found is that the ambiguity about how the engineers are going to analyze that means you can't cut them up too soon, because the engineers need to see it all as a slab, as an object, if they're following on. And the workflow that we have one example of Tim will be back to talk about soon. But like when you have a Tekla user in the same company, they're an advanced Tekla user sometimes seems to be able to do some really interesting calculations on that slab as long as it's a whole slab. So we can't slice it up too soon either. So the surface hatch was our compromise. We also were able to reassure the manufacturer that when they export that as an IFC, it vanishes. So they haven't given away their secret panel width to anybody by doing so. So it's a consensus building width. Thank you, Nikita. And in a similar in-depth analysis, like I think we're realizing that Revit has limitations, and also we're part of a young industry with new materials that it brings up those limitations. Likewise, in building tools for architects, how it looks is really important. So, and surface textures are a really growing part of the Revit landscape. It used to be you would only export these to rendering, but now more and more people are doing things in Revit that at least are giving you an idea of how it's going to look. Sometimes they're giving a natural daylighting calculation right in Revit. And manufacturers, especially during our pandemic, have been swamped with sending samples everywhere. So we decided to tackle the question of how to give architects a better sense of what the material looks like in exposed structure. With another expert we found locally, we were surprised to find that surface texture and surface texture mapping is a thing that's changing with digital technology. There's some local experts working for the solid surfaces industry, and actually our own hardwood flooring group had an example of a way to really see surface texture and tone. So I'm going to introduce Philippe Hébert from Lightbeans, tell his story briefly here and share some views of the e-sampler that he has done not only for our hardwood flooring industry, but hopefully soon for exposed timber structure.
Thanks, Eli.
Thanks, Philippe.
Nice to see you. Absolutely. All right. Hi, everybody. My name is Philippe Hébert. I'm president and co-founder of Lightbeans Technologies. We are a Quebec City-based company in the 3D artificial field vision. We are creating 3D scanning systems in our lab to digitize the surface appearance of any kind of materials. So today we're going to talk about wood, but we do more than 40 types of different material applications. You can think of tiles, textiles, even clothing, but wood flooring as well, and natural stone, etc., etc. I'm sorry for the presentation. It's going to be in French. I have it in English, but we had a technical problem. So we're a team of around 18 employees. The only thing we do is scanning materials. You might be wondering a bit why we do that. If you go on a website and you want to look at a wood, usually it's quite hard. You have a thumbnail image, and this is hard to understand the texture or even how the light will behave on the material. It's totally not the same experience as in real life. So we're trying to change that step by step. You can switch the slide. One way we tackle this challenge is with the e-sample. So we've created an electronic sample, which is a digital representation of any kind of material where we can switch the angle of the surface and see how it behaves to light. We work closely with QWEB to digitize their softwood species. It's all available on their website, and we're going to go take a look at these samples right now. So you can click. I'm going to pilot this in real time. Okay, what's your name, sir? Etienne. Okay, I've been talking to you also, so I need to know your name. If you can go back one slide, click on the catalog QWEB link, please. We're going to look at this together, if that's possible on your end. Or else I can place my computer directly. Oh yeah, you got it. If you can do it full screen. Excellent. We should have Wi-Fi too. So this is an e-sample. You see it. It's in. I invite you to click on the cursor here and drag it slowly to the right, if that's possible. This is improvisation for with him. So you're going to see the angle will vary. All right, and the goal of this is to see how the light behaves again on any kind of surface. If you can place it to the right as well, the cursor, Etienne, and click directly on the sample to zoom it. So the image will get crisper. You can drag with the mouse and appreciate the surface texture. All right. So this amplifies or boosts the experience of a thumbnail image on any kind of website. Now, of course, you cannot touch it throughout your screen in 2023, right? But it's going to come someday, maybe in 30 years. Okay. Still, if you can activate the sense of your eye, you can activate. You can activate another sense, which is the touching sense, right? If you zoom again, Etienne, even though I can touch it in real life, I can still understand a bit how it will feel, right? So we don't have the pretension of replacing all the physical, not at all. Okay, it's more in the pre-shopping phase. A lot of samples are being sent in the world. Different countries. So if we can just have a better view online of the material, the surface species, that's way more interesting, right? But then you're going to have to touch it, you're going to have to see it, especially if you're doing a big project. So this is the sample. We've digitized ash, aspen, basswood, beech, cherry, eastern hemlock. I think Eli, something around 25, Alex and Eli, different wood species. So the usage of this thing is we implement this on the website of the manufacturer. This can be used on any kind of website. You guys could have it if you had a website, for instance, you'd like to better show these images. Or it can be also sent by text message or email directly to an architect or designer. The architecture firm can share it again within his team. So thank you, Etienne. We can go back to the presentation. And you can switch slide. The next thing, some speaker yet have talked about this. How can we implement these into 3D software, right? Because I was talking about the web. Now, more and more architecture firms need to do renderings. It's becoming the norm, depending on where you are on the planet. But so what happens right now is only a few manufacturers give the textures, the visual textures to the A&Ds, architecture firms and designer firms. So what we do here is called a smart texture. Okay, so what is a smart texture? Because we're used to the concept of a texture where you can download any kind of wood or flooring and just place it into your project. Now, a smart texture, also called PBR in most more technical field, physically based rendering material. What it means is it reacts to lighting dynamically, like it would in real life, compared to the textures today. Textures in computers, in 3D software, they are called flat textures, so they only have the color information. When you look at a rendering, sometimes you might say, I know it's a rendering. It looks a bit plastic or it looks a bit cartoonish. So if you have PBR textures or smart textures which dynamically responds to lighting, it enhances the photorealism of any kind of renderings, right? So, and it needs to be easy also to integrate. That's the first thing, and usually it saves a lot of time. If the architect or designer doesn't have the texture in hand, he has to create it in Photoshop. Maybe some of you here have tried to photograph a wood and Photoshop the wood and spend half of your day on that, or 30 minutes, an hour, and say, oh my God, why do I don't have the high-res? So if the manufacturer can give that to the A&D, it's a game changer, in my opinion. So let's see in a more concrete way what are PBR textures in real rendering. So you have some examples. What you see here are not images. They are not pictures. They have been done with the wood flooring manufacturer called Proverco, which is part of QWEB. So PBR texture allows us to dynamically integrate the wood into the scene and do close-ups as well, simulate any kind of lighting, and it will automatically vary. All right. So a lot less time to produce these images than if we wouldn't have the PBR texture. Etienne, you can switch slide. Yeah. This is another example done with the PG model manufacturer, wood flooring manufacturer company here in the province of Quebec. So we've digitized their planks. And the wood floor, we're talking about more than 30 planks we need to digitize because you want to have the complete variation, right? If we would digitize just one plank, it would be a weird rendering. You wouldn't want to buy that flooring. So this is an example, multiple angle views. You can switch slide it's into. Close-ups like this. We're trying to simulate basement homes, ground level, just to familiarize the user and see how the product could look like in an environment from here. This is a training room there, but everything you see, it's not a photo. So I'm going to introduce you to what PBR can do in the future, just to give you some ideas about what's coming. Okay. So this is again a rendering. Etienne, if you could click on the rendu dynamique link, please. Dynamic render. So render will, you can even place it full screen just by clicking on that button, top right button, if that's possible. Okay, never mind, it's all good. So renderings, they are static today. You're starting to see walkthrough, maybe a bit, some movement in the renderings, but with the lighting, it becomes very interesting if you can play around with it. So it's in, you can again drag the cursor slowly to the right, and we're gonna change, as he's dragging the cursor, we're gonna see the room change in terms of lighting. Everything, the wood, we've digitized the wood here, it automatically reacts to different lighting of the day. And this will create an emotion or at least enhance the presentation of projects. We're really in the interior here from what I showed today, but you can do the same in the exterior, any kind of point of views, right? Yeah, you can bring it to the left. All right. Thank you, Etienne. You can. I have one or two more slides just on the finish line, so you can switch. So we, our model is we work directly with the manufacturer, but we release a texture bank on the site. It's free for every architects and designers. They are all PBR. There are hundreds of textures out there. You can go and download them right now or after. And if you skip the slide on this one, this is just an overview of the platform. So there's multiple material, mostly wood. We're going to do the wood species, the softwood species soon in terms of PBR. So thanks for your time and listening to this small presentation. My name is Philippe, and glad to meet you, everyone. Thanks, Eli.
Philippe. Thanks, everybody. So with this kind of talent, obviously the Manufacturers Association is trying to figure out how we can put this to work for the industry itself. So we can't wait to see this on the ceilings. Obviously, it's going to be really cool.
Yeah,
and
absolutely.
We're going to start out with a viewer that catalogs many different types of mass timber and exposed ceiling structures. Flip it upside down, shine the light from below, and then proceed from there into all the Revit texture stuff as we can gain consensus and funding for that. But questions for Philippe?
Yes, Nick.
I'm wondering, we saw a rendering earlier. What tool were you using for the specific rendering?
We're using the modeling tool, Nick. It's called 3ds Max, and it was rendered in Corona rendering. Yeah.
The next step is to put the paint into wood, so you can see every different type of color.
Yeah, like color transfer. Yeah. What you mean? Yeah. We're working on that. There's the challenge. Sometimes they have the brands have a lot of SKUs, so preparing all the samples sometimes makes no sense. It can goes in the thousands, so we need to work on the color transfer from one specific wood species to create all the possibilities. We wouldn't have to scan like 1,000 SKUs, right? So we can do it digitally. That's the future, not so far away from now. Not in 30 years, compare if you could touch it in the screen.
That's really interesting. I'm just wondering, are there any thoughts maybe in the future to look at how people react to the different patterns? You know, it's just the biophilic benefits to the texture and to the lightening. I know this is probably in the longer term thing, but that would be an interesting thing as well.
Like the reaction on the computer screen? Is that what you mean?
React to different colors, to the different textures, the different type of coatings.
Huh.
When the light, like in the typical rooms that we showed up, it's just the biophilic
I see.
effects, we call them. This is really important for living and working in a mass timber environment when everything is exposed.
I understand. Maybe we can talk after the presentation.
Got a question for Jesse. From Jesse.
Thought about partnering with a group like there's one called Material Bank that sends out samples instead of people are receiving so many physical samples being shipped, but maybe they can limit the number of samples if they were to have a better visualization first.
Yeah, absolutely. It's a good point. Are you from Material Bank or? Okay.
Contacts there.
Okay, yeah. Okay. We're currently in touch with them.
Okay, awesome.
Yeah.
All right. Well, so I don't have to take your lunch hour away. I'm gonna move everybody along. Thank you so much, Philippe.
Thank you, guys. Thank you, Eli.
And yeah. So it's obviously a big challenge to render and show materials. An even bigger challenge I'm going to set the stage for with the next speakers are going to be how to get a fair comparison. So as you know, we've been trying to help architects comparing wood to other species or wood structures to others. And the carbon calculation space is so challenging that I needed an army for this one. So there's going to be 3 sequential speakers speaking about the art of a fair comparison. And I realized that even comparing 2 materials is not an adequate way to go about the challenge. If you're comparing 2 structural systems, there's a bunch of stakeholders to that. And the life cycle analyst may be expert, but they need the engineer to go first and say what is the work being done by 2 structural systems. It's not just a matter of how much, you don't have the same amount of steel and the same amount of wood and the same amount of concrete. You have 2 or 3 structural systems doing similar work. So I'm going to start out our presentation on the art of a fair comparison with an engineering study, once again done by my friends at Mass Timber Consulting, and not having known yet that I was going to have a super detailed and talented teammate on the art of, if we're starting with engineering comparisons, let's get an engineer to start with saying what's doing the same work. So, Alex, can you help me say your last name, and then we'll go from there.
Yeah. Hello, everyone. My name is Alex Chygryn, and first of all, I want to thank you for inviting me here and letting me speak about our collaboration work between QWEB and Mass Timber Consulting in the field of estimation of the carbon footprint in the construction industry. Because the estimation of the amount of embodied carbon in the structure, it's an important task for the reduction of the overall carbon footprint. It's a very popular topic, and currently there are several institutions that already launched the initiatives providing the databases with how it's called, embodied carbon estimation and the environmental product declaration databases. And they also launched the initiatives with embodied carbon estimation calculators and estimators. So as example, it is the 2050 commitment to net zero program by the Structural Engineering Institute, which they introduced the estimator, which works in the next way. Basically, you can enter the approximate amount of material that could be used on the construction site, and then the calculator will estimate the overall carbon footprint based on the EPD information. Obviously, this estimation has a downside. It's very preliminary. And that's why we're proposing to use the 3D modeling for the estimation of embodied carbon in the construction. And the main advantages of 3D model is early stage design assessment data. So by modeling parts of structure or structure in total more or less detailed, we can already see some data, how it's going to affect the overall carbon footprint. The visual comparison also could be involved in that. But at the same time, the model should be well detailed to get more or less good estimation, and the software should be capable on a cross-platform exchange of data to transfer the information to BIM model or to just review it in HTML file. So we were working on that, and we decided to use CADWork as a program. It is a CAD-CAM program that is capable on the high-level detailing, and it's meant to provide information for CNC machines to cut the materials. So this is basically what I did talk about, but forget to change the slide, right? Our next step was to create a catalog of structural materials and assemblies with the properties that will match the data in some EPD catalogs. And by doing that, we reached to the point when we were ready to start creating the actual model. We had a moment to think about what should be the base conceptual module to compare the different construction types. And we came to conclusion that the modular construction, it's a gaining popularity type of construction. And they use steel as the main material. And at the same time, the steel elements are well standardized. And it's easy to get information from APD catalogs or the information of the precise shape and the amount of materials in steel when they're going to be used. In the end, we designed a few types of modular blocks in a variety of size, both in 40 feet long and 80 and 14 feet wide as the base. Those elements, the structural elements were engineered for the block stackable up to 3 levels for typical residential construction. So all elements, all structural elements were modeled based on the industry standards in high precision with all additional information such as insulation and so on. I will present it on the next slides. So the walls for this block module made of steel were made with steel profile studs and designed using the iTool, online iTool by Clark Dietrich. This is the manufacturer, and they have good information, precise information about their product. That's what we've used to precisely model it. And the reason why it's a Clark-Dietrich, because their systems are high-tech designed, and we assume that this is going to be the good case to compare with the other types of construction. Also, the walls, including the layer of insulation, the fiberglass exterior sheeting, and a gypsum board interior sheeting. The model was designed very detailed, so we even included the fasteners and all connections between studs, and this was done because somehow all this data should be taken into account, because Revit model, for example, it's more to say like for entire building, but we somehow wanted to provide the high-level detailization. The floor system was presented in two variations, with traditional open web I-joist, and the joist and the rim track by Clark-Dietrich. And we also use the standard of manufacturers to precisely model it. The next step was to create something to compare with, and we modeled the stackable module made of timber to match the size of the base conceptual models, also up to 3 stories of residential housing. And all timber components were modeled based on CSA standards. Walls designed following the light frame design recommendations and standard details. Structural performance of the floor provided with Triforce open web I-joist and proprietary connectors. Once we had models to compare with, we tested the ability of the program to transfer this information to other software for the further analysis. On this slide, you can see the example of tabulated data for the cross-platform exchange, where the different EPD catalogs can basically, this list can be integrated into EPD catalogs, and the information can be pulled out of the published catalogs to assess the amount of carbon in the specific materials. Also, about this exchange information, I want to say that we came to conclusion that the best way to estimate the amount of carbon is to bring everything to one unified unit of measurements, and it's a volume. Because other materials could be measured as a weight or as a surface or whatever. So in the end, as conclusion, we received data for the further analysis, and we developed the conceptual archetype block in several variations for modular construction. My presentation is over, and I will be happy to answer your questions. Thank you.
Great job, Alex. Thank you.
Thank you.
Well, excellent. We could also, since I'm stacking three linked presentations in here, we can also maybe face some more questions from everybody at the end. It's super helpful in this example also to realize that using a modular industry or a module as a building block really offers a lot of further study and needs further study, because number one, I think the life cycle industry has been driven mostly by engineering discussions, and it is true that the structure has a big a big role in the footprint of a building, but actually the architect continues to have a lot of impact throughout installation and finish. So we love the fact that modules actually give us a chance to look at impacts for all those layers. Also, taken in a literal sense of view, the modular manufacturing industry is the most regional of all of them. The transportation is limited. Also, transportation is fairly simple to calculate because there's one module per truck. So it gives us a really good laboratory to start getting into the fact that prefab is regional, materials are regional, and a lot of, even once you know the quantities and we can process all the good information from our engineers, there's a whole other layer that begins to kick in of how is that regionalized and what is the data that we can add to that and how does that play differently between regions. So as my chaperones on that topic, I've had consistent help from a life cycle team at Ageco, both on the strategic advisory level, on training materials, and also on helping us develop regional material databases and even potentially predicting or anticipating as new materials come in, like wood fiber insulation, how can we show now what an impact that will have when there still are no EPDs for this here. So on that front, I'm going to bring in the life cycle analyst role in a regional expert dashboard and Alban Pilard from Ageco.
I'd have to say, Eli, I'm always impressed as how you're able to gather great minds around the table. Every meeting is the same. And I'm glad that also that our American friends, they get to experience the Quebec weather like a full experience. So my name is Alban. Yeah, perfect. My name is Alban. I've been involved with the Ageco team based in Montreal and Quebec for the last 3 years now. But Ageco has been involved with QWEB for the last maybe 10 to 12 years, more of that. So I've been involved in the wood sector and also aluminium sector since I started, mostly at the EPD development level, wall building LCA, and like Eli mentioned, on a strategic advisory, and just like giving QWEB where LCA stands for when we want to implement carbon data into wood construction. Before starting, can you shout at the same time, what is, from 1 to 10, what is your level of knowledge about EPDs? Just like 3, 2, 1, what is, from 1 to 10? 7, 5. Okay, so I'm glad I've got some contents about EPDs, just to give you an overview. Shall I click on this one? Yeah. Does that work? Is that super? Yeah. Did you do it or did I control it? I did it. Okay. So I make you a sign every time. Okay, thank you. I'm not alone in the team. Elsa, my colleague, is there, and you're gonna meet her at lunchtime. And we are more than 40 professionals now. We are involved in so many sectors that I cannot know all of them. And we are involved in the banking sectors, in the food sectors, in chicken, in beef industry, in aluminum, everything. And all those sectors, they combine and they benefit each other because we learn the methodology from other sectors and we bring that knowledge into wood industry with what we've been doing with QWEB. Okay, perfect, thank you. So today, EPD, LCA, biogenic carbon, and the challenge we have. That's it, that's my content. So first of all, what's an EPD? I don't know if you had breakfast at this facility this morning, but you know, when you are having Fruit Loop cereals or when you're choosing a product in the supermarket, you look at the nutrition sheet, nutrition information about the product. You know, those are the health and nutrition values of the product. Well, EPDs is the same, but for environmental impacts for a product, not an assembly most of the time, for a product, a material. it's not made out of the blue. It's based on international standard, international and recognized standard. They are based on ISO standard. And so ISO norms are the, like the more common guidelines. And then we have to follow what we call the PCR, product category rule. So those are specific rules that if you want to develop an EPD, so a nutrition sheet for a wood product, you need to follow specific rules that apply only for the wood industry. So that what you need to make sure that your product that you are assessing is comparable to another one that some other people are doing in another country, in another province, in another city. So we need to make data comparable, and PCR and ISO standards ensure that. It's kind of a recent thing, I would say. It started in Europe. As Eli mentioned, Europe is kind of in advance for every carbon calculation and stuff like this. And QWEB has been developing some, well, we and QWEB have been developing some EPDs at industry level in the last I think it started in 2016. So it's pretty recent. And it's the same in every industry. EPDs are new to the market. And it's getting more and more attention because, like, for example, the Buy Clean California Act now requires some people, when you're bidding for a project, to give some data about what are the materials that you're going to use, and do you have EPDs for them? Do you have carbon values for them? Just to mention, EPDs, this is not only carbon values, it also has a lot of environmental indicators, but today we'll mostly talk about carbon. So as I mentioned, with QWEB, we developed 4 industry-wide EPDs. Of course, in Quebec, you have access to also specific EPDs. I think maybe, Eli, you showed the Nordic EPDs, and we talk about them a lot. They have a specific EPDs for the CLT. But with the QWEB, we've got 4 available EPDs that represent the environmental impacts of, let's say, for example, light wood roof trusses. And manufacturers and people that want to know this information, they have access to it publicly. As a comparison, we did the same with the steel industry, because we were talking about steel earlier. And so for the wood, we did that with 3 manufacturers. We gathered the data, we published a document. For steel, we did that for 77 manufacturers all across Canada. But steel is much more, I would say, a simpler material. So we did that for steel plates, the section, the hot roll structural section, and the hollow sections. That's it. But EPDs, they are found everywhere in a building. Like in this building, for example, you take every material, there is 99% chances that you will find an EPDs available publicly. Like we've talked about the EC3 database that kind of have most of the EPDs available in North America. This slide is in French, but you can understand that for a vapor barrier, we've been talking also about curtain walls, you have EPDs available. Most of them, they are industry-wide. That means they represent the average impact of a curtain wall of a vapor barrier, but it's not linked to the specific manufacturer most of the time. And this is one of the challenge. Other challenge is, and I think Kasia is going to talk about that a bit later, but in EC3, so the EPD database, this is just like, I don't know if I'm authorized to show this, but I think Kasia, you have got the same image, but in EC3 database, more than 40,000 of EPDs are from the concrete industry, those guys from concrete. And we've got like less, I don't know if it's, I don't know where we stand at for wood now, but it's less than 10, around 10. So concrete finishes and thermal barriers, EPDs, they are everywhere in EC3, but wood product, there are not as many EPDs. So the problem with that we have a lack of easily available data for anyone who wants to develop or to bid for a project using wood product. as I mentioned earlier, EPDs, because of the PCR and because of how it works, they are often linked to one specific material. And because from our understanding now, the work we've been doing with engineers and architects, now our structural knowledge of wood is better. Wood is never used as a simple material, simple component. There is not a layer of wood it's always used mostly, and correct me if I'm wrong, but it's mostly used as an assembly. And PCR and EPDs, they're not fully, I would say, ready to show some full assembly. Of course, we've seen some I-joist, which are assembly of wood product and glue, but we don't have wall panel fully with wood insulation or with other insulation. We don't have EPDs with this data. That's kind of exactly what we're developing with the brilliant minds in this project, to have some easily accessible data for a full assembly that includes the data for a wood product. So it's not EPD that we're developing, it's like assembly carbon data. Like I mentioned, we've done the work with the 3 manufacturers, and so this is industry-wide EPDs. But when we want to assess the carbon footprint of a specific building that has a specific list of manufacturers, we need to know, well, most of the time, architects or engineers or the builders, they know where they source their material from. And so one of the things that is cool with EPDs is that you can develop specific EPDs for a specific manufacturer and easily adapt maybe industry-wide EPDs to a specific location, and so that you have the exact carbon emission and carbon accounting for your building. EPDs now not made by themselves. They are based on LCA, life cycle assessment. That's what we do at Ageco. Roughly, we've talked about LCA and Eli mentioned it a lot. This is just a summary. To give you an example, when you develop an LCA, so a life cycle assessment of a product, a material, a service, just assess every flow that comes into it. You gather that, you transfer that into indicators, environmental indicators. How do you do that? By asking questions at every life cycle stage. So if you have curtain walls, if you have a wood truss within your building, we're going to ask, where does it come from? Where the wood comes from? Where has it been harvested before? So we kind of all along the value chain, we ask questions. Even if you don't have the answer, we're going to make assumptions, and we're going to kind of work with you to know if these assumptions make sense or no, because you have the data, and we know how to model it. Just an example, and Eli will talk more about that in the future, because it's really recent studies that compared a group of material. So materials are the group for a concrete building, well, mostly concrete, and glulam CLT building and LVL CLT building. And they are showing the carbon emission of the whole building based on the structural material. What can go wrong at this level? Many things. But, when we compare things, we need to compare apple with apple. And Eli, you've mentioned that we need to be really taking care of what we're doing at this moment, because at material level, when you compare two materials, the functional equivalence is kind of easy to prove. Like this chair is equivalent to this chair because the function is to allow one person to sit. But on a building level, when you've got some assembly, it's not as easy as it seems, because we need to assess the equivalence on a performance level. And we don't have the knowledge to do that, because we don't know if the assembly that Eli is presenting us, if this assembly is has the same installation performance or acoustic performance or fire rating than another one. So that's why we all work kind of together with engineers, with architects to understand, okay, if we want to compare a concrete slab or a CLT slab and flooring as a whole, yeah, we need to make sure it's a functional equivalence. Just like a few words about biogenic carbon, because Eli, you mentioned that very well at the beginning, so that you know, because in the wood industry we've been talking about biogenic carbon more and more. Biogenic is like, you can oppose that as fossil fuel, fossil carbon. So the biogenic carbon is the one that is captured by the tree when the tree grows, and it's every human being, every species living that capture or emit CO2, carbon dioxide, it's basically called carbon, biogenic carbon. Every carbon that emits from the combustion of fossil fuel is fossil carbon. That's it. There's nothing else to know about carbon emission, about biogenic carbon. The thing is, with the wood life cycle, you've got carbon capture when the tree grows. It's the main boxes on the left. Like, this is where you have the most, well, this is the only time where carbon is stored into a product, but it's stored in every part of a trees. And some parts of these trees are leftovers in the forest, and they decompose themselves, and they will re-emit the carbon that they've stored because they decompose, and it's aerobic decomposition, so they will re-emit that. But when you are building a plank, this carbon, like 50% of the volume, 50% of the mass of a plank is carbon, and so it's equivalent to, you multiply that by 3.6, and we have the equivalent of carbon dioxide that is stored in the plank. And the difference with the steel making industry is that when you produce steel, the emission from burning coke and stuff is done at the moment when you produce the steel, and then there's no emission after that. So the harm to the environment is done. You cannot do anything about it. But when you harvest wood, and so the carbon is captured, and the emission is not made at this point. When you've got a plank, or a CLT, and then you make CLT out of it, and then you dispose of your building in 100 years, in 50 years, the emission is going to take place in 50 years. So you kind of delay the emission, and it saves us time with like environmental challenge and climate change. So finally, where we stand with within the QWEB team, I would say, what we need at the moment, like mostly to work together. Eli, you said earlier, I took notes, why don't we show our data more? And we need to give defensible info to the sustainability advocate of a team. Well, they need that information. They're not gonna invent it, and we need to provide this information. So that means maybe EPD for every wood product that we are working on at the moment. And like I said, we need to have regionalized data, so specific data for every manufacturer. Maybe like the texture that you've been presenting, we don't need to model every manufacturer, but maybe have an equation that can be used and that can be adapted easily without asking the question to every manufacturer of wood, because we've got tons of them in Quebec. And like Alex, you mentioned also, like the order of magnitude, the range of impacts. This is specifically important for a new product, because when a new product, let's say wood insulation, come into the market, there is no guidelines to assess the life cycle of it and the carbon footprint of it. because it's new and nobody has thought about it before. So for that, we cannot assess an EPD easily. What we do is that we need to assess the order of magnitude. What do we expect from this product so that architect can use them easily and as quickly as possible before the EPD has been done. And I'll let Kasia, I think, talk about the frameworks of how we develop the stuff. But just what I took notes here is, Nick, you said we want to simplify the life of the end user. That's what we want to do, like, exactly. The carbon data is not a data that you're gonna invent, that gonna come to you. We need to feed the data to the people that are using the models, even attach them to a Revit library, a Revit family, as in the tables. But we need to put this data out there from the Quebec manufacturer, and that's what we're doing with the Eli. Thank you.
That was awesome. Thank you, Alban. So you can see that even with the engineers and the life cycle experts we had around, I was starting to get to feel like this was too big a challenge certainly for my head. I wanted to go back to the forest and stand and look at what was going on there. But luckily there were some big data experts in the wings. We decided to ask a team that was already doing some work for NRCan on a larger level to scope out a project for us. We weren't sure that it would ever involve artificial intelligence, but we knew that we needed really big data experts involved. So at that, Kasia, I'm going to let you take the floor here.
Can we have the next? Hi everyone, my name is Kasia Borowska. I'm Managing Director and co-founder at Brainpool AI. My background is actually in mathematics and cognitive science, which is building mathematical models that predict human behavior. So for me, it's a pleasure and honor to be here around experts in this field, which I'm still learning about. So I don't want anyone to be put off by the title of my presentation. I know AI is still a mystery to a lot of people, and it's a bit of a buzzword these days. But what I wanted to focus on is how these new technologies can be useful for us. And we all have the same objective in mind, which is essentially to reduce the carbon emissions of our construction projects. But Eli very rightly said at the beginning that one of the biggest challenges we have is that there are so many experts involved in this process and so much data, so many different tools, softwares, that it's really difficult for us to share that expertise and to collaborate. And we think that technology can actually make this collaboration and sharing of the knowledge much easier. And carbon fixers is really one of the projects we're mostly focused on at the moment, also mostly proud of at Brainpool. And my presentation really is just an introduction to the next presentation, which will be done by Andrew, which is one of the key developers of carbon fixers. But I wanted to just set the scene and explain what we're trying to achieve. So what we can see here on the slide is the kind of infrastructure and the landscape that we have with every single construction project, which is where we have our EPD data on the left, and really it's an overload of data. As we know, it's a very complex kind of technologies and also analysis that goes into producing those EPDs. And then on the right, we have architects and developers, builders who need very quick and instant access to that data. In the middle, we have engineers, regional experts who are trying to make sense of that data for the architect's benefit. And that's why it's so difficult for us to actually be able to quickly and instantly provide this information in a format that the architect needs so that their decisions can be influenced by the data that's included in the EPDs. And so what we've done is divided the Carbon Fixers platform into two sides, so the admin dashboard and the front-end application, which is visible for the architects. So within the admin dashboard, we have access to all of the EPD data, and thanks to the very complex back-end engineering work, we actually managed to present it in a very visual and easy way for architects to understand. So regional experts, structural engineers, and lifecycle analysts can instantly build sub-assemblies using the real live data stream coming from EPDs and make that information available to architects on the right. And so what we have is data that's open, transparent, and accessible to everyone globally, because Carbon Fixers is fully deployed in the cloud. We have version control system, which enables architects to quickly compare different versions of their project according to the kind of expected CO2 emissions that they can expect given the materials they use. We have centralized environmental databases, so all of the EPD databases go into this one central system. REST API accessible, meaning everyone can plug in to those databases and get instant access to the information across a range of manufacturers. Real-time analytics, so we can instantly analyze that kind of impact that our decisions will have on the overall CO2 emissions. And instant like-for-like comparison, so we can see what will be the implication of our decisions at the early design stages. So this is an example of how this works in practice. So here we have an admin dashboard where we can build our custom assembly. We give an assembly name, building family, subfamily, so all of the details. We then have that custom assembly visible within the admin dashboard as well as the front-end application. Within that, we can then set parameters, dimensions, as well as fire resistance, thermal resistance, and all of the other aspects of that particular assembly that we want to evaluate. So that's happening within the admin dashboard, our expert dashboard, and then that information is instantly available for the architect. So the architect now has full information on how the embodied carbon will vary according to the assemblies that they have within their particular project. So that information is much more digestible for them, and it's instantly accessible for also to be able to compare the kind of implication that their decisions may make. So for example, an architect may want to change this particular wood component into a steel component, which you can see here is very clearly presented. Okay, if you do that, that's great. Your building will look different or will look in a way that maybe you prefer to look, but this is the implication on the embodied carbon that your decision will have. So hopefully this platform will give the decision makers an ability to take embodied carbon as one of the deciding factors when making those decisions on the materials being used. And so overall, what we're trying to build is a way for lifecycle analysts, structural engineers, and regional experts to collaborate. So every single component of the admin dashboard is editable, so users can actually input the information that they have and the expertise they have. So everyone can share their expertise. For the first time, we've built a platform where regional experts can communicate with each other and really have that open discussion on how the different information that they have on EPDs and other information coming from their live projects it impacts the overall implication of embodied carbon for the given project. So we have that collective intelligence capability where everyone learns from each other and shares information with each other on an ongoing basis. And with that as well, we hopefully can embed more technologies to really continuously develop that collective intelligence and help us learn faster and build the knowledge that we have about the different implications of using wood versus other materials within the construction project. So what we can see here is an image provided by Ageco, but we can see the complexity of the whole life cycle, right? So there's so many different experts, so many different stages, so many different types of hardware, software, and expertise that's required, which makes it really hard for us to actually be able to efficiently evaluate how this whole project should be run to minimize the overall CO2 emissions. So we hope that with the help of platforms like Carbon Fixers, we will facilitate the collaboration between these different types of expertise. So the processes, the people, the different layers of intelligence can overlap, and we form this shareable knowledge bank of people that can actually exchange information to enable us to learn from each other. And in the future, obviously, we have many other ways in which AI can help. So artificial intelligence has the opportunity to not only build collaborative systems and collective intelligence, but also predict how our decisions will impact on the future of construction projects. We know that embodied carbon is just one of the factors that architects and developers need to take into account. There will always be other factors that will be important, such as price and other implications of creativity, arts, and so on. So we want to make sure that over time we will have more and more data embedded with Carbon Fixers, so we can plot data points such as price of timber, population growth, market dynamics, global events such as pandemics, inflation. All of those data points have an impact on the decisions that are being made. And we want to make sure that embodied carbon plays a top role in that decision-making process. And hopefully, on a global level, then with time, we can use technologies like Carbon Fixers to make decisions that are more optimal for not just us humans, but also for our environment. And now I'd like to welcome Andrew, who will go into way more in-depth details into the Carbon Fixers app. Thank you.
Super, thank you, Kasia. I'm going to introduce Andrew as we come up, just because he needs a little introduction here. But so as Brainpool scoped this project out, and I was sort of apologetic, saying I don't think we're ready for AI yet, but you guys have really helped us understand the big data. They said, well, we actually have really gotten excited about this project too, and even if there's not AI yet, we'd like to build this for you. And we think there's some good young people who really want to bring their skills to bear on this industry and not just on financial services or healthcare. So with that brief introduction, we got a chance to meet Andrew Norris as he graduated recently in Ontario and jumped into this project with really both feet. It's been great to have you on the team, and now I'd like you to share what you've built in 3D.
Sweet. Yeah. Thanks, Eli. Okay. So I'm here to talk about version control and carbon using Speckle's open AEC platform, collaboration platform. So I've been working on Carbon Fixers for about a year and a half with Eli directly. He comes and goes and meets all of you guys and then comes back to me and is like, I want to build this now, and he comes up with new ideas. So about 6 months ago, we got into his head that version control would be a really useful thing to have on this platform. And so with that, Speckle is something we'd been using in the past for sort of volumetric calculations, and we saw that it would be really useful to actually build it around its version control system as well. So there's a big collaboration between what Speckle provides as an open source platform and what we do on Carbon Fixers. So on Carbon Fixers, we try and aggregate carbon data regionally so that we can give accurate estimates without the industry really being there in terms of EPDs, especially on the wood side. And then we create carbon estimates from these prefabricated assemblies that Kasia discussed were being created on the admin dashboard. And we can give you a comparison on a components level, a materials level, and a transportation level. And for Speckle, it's a platform that exists on its own as a cloud-based version control. It allows interoperability for 3D models across various platforms, or various programs that I'm sure all of you are familiar with. It has modern collaboration tools, so in the age of asynchronous work and remote work, you want these kind of tools that the building industry probably doesn't have great ones yet, so we're hoping that this can be one of them. And automated pipelines to kind of make a lot of your work happen before you wake up in the morning. Stuff will be ready for you that your coworkers have been working on. So just briefly, I want to talk about the API. This is sort of separate from the stuff that we work on, but the entire project is based on it. It's pulling the EPD data from Building Transparency's EC3 data right now, and we have goals to expand that to other data sources to try and make this more global and more accurate as that data comes in. But we've built this API on GraphQL, so instead of getting an EPD that's like 200 fields, half of them are null and have no information, you can just select exactly what you want. So if you want an average, a best, and a conservative estimate on the GHG output, the density, the name, and the mass, you can get that instead of filling your calls with useless information. But moving on to the actual application that we have here at Carbon Fixers, we're trying to help architects make estimates on their carbon. We want to present them data, and we want to be able to let them make comparisons so that they know what their carbon outputs are going to be. So I'm going to give you a scenario here and kind of walk you through a demo. So if you're in charge of making a new office building, you want to know what the materials you should be using are, and you have strict requirements for your thermal, your audio, and your fire ratings. And you're good, it's 2023, you want to keep your carbon footprint as low as possible. The first thing you're going to do is you're going to go into our app and you're going to set up your building. So you're going to be creating an office with a multi-story grid. It's a 20 by 20 foot structural grid. And then you're going to create a 60 by 60 two-story building. So you're essentially going to have a 3 by 3 grid across 2 stories with these bays. First thing we do is we give you a 3D model of your building. We want you to be able to visualize what you're actually creating here. Right now it's just the floor simple structure. You might recognize the kind of transparent low LOD model here. This is directly from Nick's family that we've brought into Speckle, done some vector math on, and created a larger model to kind of allow people to visualize very quickly what they're working with. Then we move on to the filtering of the assemblies. So the goal here is to have a large number of assemblies with tons of different requirements and tons of different regions. But scrolling through a list like that is going to take you ages. So we want architects to be able to come in and say, I want a low fire rating, I want a low acoustic rating, and a low thermal resistance. I don't have that high of requirements, but I have some requirements. I want it from central Canada, and I want the governing span to be 20 feet. So you can easily filter on these huge number of assemblies, which will exist hopefully in the future. But for now, we're going to go and we're going to get an assembly here. So this is Nicolas Catellier's 20 by 20 light wood frame family that's been ported into Speckle as a 3D model. We can look at the right side here. We have a material breakdown. So we can see all of the different materials pulled from Speckle and their volumes, and then an embodied carbon. So we're showing right away the important information to these architects when they're selecting their assemblies. We want to show, we want them to be immediately available what they're working with. But there's even more information if you want to go into that. So we can go in, and the first thing you'll notice here is maybe the version history on the left side. So Nick has worked on a couple different versions of this. This is the first version that's actually been approved by Eli, as you might see down on the bottom. So it actually meets the ratings that he wants. But what those versions are is actually, they're all these Speckle objects. So every time Nick makes a change, he can upload that change to Speckle, and Speckle will keep a change log in history, so we can go back and see the old versions. And this is something called version control. The version of the way you guys use version control probably now looks a little something like this, where you have all your different files in one folder. You've named final 3 times. You've edited them. It's not great. It's not great for collaboration. It's not great for editing. It's not great for organization, but it is the common method that a lot of people have. As a developer, we've been using version control I've been using it for 10 years. It's been around for 20, but it is developed into a very structured way to manage our code bases. We wouldn't be able to deploy applications in the way that we do if we didn't have some form of version control. And this is just a simple way to use version control. It's expansive on how you want to, but we have a main branch that is the code that's on a website, so that's the code that's actually being used by people. We have the ability to branch off of that to create a hotfix in case we just need something that's out there fast without messing with our development flow. We'll have a branch that's maybe 3-4 features ahead of what's out in the world, and we're working on that continuously until we're ready to put that out into the world. And then we have feature branches. So every time someone wants to make a change, we can work asynchronously. My coworkers in Manchester, me here, and we're not messing with each other's code base. We have separate file systems, and we can put them all back together at the end. How does that relate to the building industry? That is what Speckle is trying to provide to the industry. So you say that you're trying to present your assemblies to your boss, and you want to show him the comparison right away between a steel and a wooden I-joist. So you can create the same assembly up until a point and then split up when you add the joists. And you'll have 2 different versions that are existing at the same time on the cloud that they can access directly. No longer are you saving these files locally and sending a million off in emails, and then when you're going back to look for it, it's completely lost to time. It's all on one place and very well organized, as well organized as you can make it. So yeah, that is how we're using version control to kind of allow these assemblies to exist across time versus just being one single file that exists somewhere. We're going to allow them to build upon themselves and be iterated upon. And that kind of comes into these ratings that we've talked about previously. So the fire, acoustic, and thermal ratings. We want people to be able to build assemblies, experts to build assemblies, and then we want other experts to be able to come in and actually say that these assemblies do what they do. We want to have this collaborative tool where we have teams of people coming together and saying this is good data, saying this is trustworthy, so that when an architect comes in here and they want to choose this assembly, they can look through the history of who has said yes to this, who has approved this, what has happened in the history of this, how do we get to the point where this exists now? So Eli is our approver here right now, but he's come in and he's approved this assembly for these 3 ratings. And he's actually come in and he's commented on the BIM object itself to say that this is approved. So one of the features of Speckle that allows it for such tight integration with collaboration is that you can comment inside of BIM. So no longer are you saying that the 3rd floor window in the back room is a little too small, let's increase the size. You can go into the Speckle object and you can click on it and you can write a comment, and then the other users will be able to see that comment and no longer have to imagine in 3D space what they're talking about. You can actually attach things to BIM objects, which makes for very easy collaboration in a space that's very complicated. So yeah, moving on from that, we have how Speckle actually works on our side. So you can see that this is, we don't just have to see the whole object as a whole. This is a fully detailed BIM object that we can look at. We have probably 5,000 lines of JSON describing this object. Not very readable for you, barely readable for me. But for coding, it makes it very easy to interact with Speckle as a platform. So it's actually built for developers. It has developers in mind where we want to modernize the building industry just as much as everyone else. And that means using code, and it means developing these third-party platforms that will hook up to BIM objects and allow us to look at all of this information that has now been created that didn't really exist that long ago. Sorry, one sec. Yeah, so you can build a third-party application that if you're a joist manufacturer and you have a number of joist products, we can link your Speckle commits to the latest version of those joist products, display them on a website somewhere, and then your clients can see them directly and kind of interact with them there. we can build applications on top of this, which makes it very easy to access all this BIM data instead of just having CADWorks embedded in your browser somewhere. But another big part of what Speckle is and why it's important that it's big for developers is that it is an interoperability platform. It is built with the idea that a BIM object is a BIM object is a BIM object. If you upload a Revit object to Speckle, you can pull that same Revit object into AutoCAD. You can pull it into Rhino. You can pull it into Grasshopper. It's going to preserve your BIM object as a Speckle object, and that is incredibly powerful. So maybe you want to get material breakdowns in Excel from your Revit object. You upload it to Speckle, then you take your Speckle connector to Excel, and you pull the same object down. It exists as one single object, but any program can connect to it and pull that object out from the server. So maybe you want to do Grasshopper and Rhino scripting with your objects. You can do that through Speckle from Revit. And not only can you do that, you can actually automate that process. So every time that a Speckle commit is created, you can hook up an application to listen for that event and then run certain tasks. So if you have repetitive tasks that are happening every day, that someone is going in and doing the work and running the scripts, these things can be automated through Speckle. And that is going to save you guys time, and it's going to give you a lot of opportunity to free up and do other things with your time. We use it we can use it so when a commit is created on these assemblies, we can automatically populate that in our database with carbon data. So we don't have to have someone go in and say, hey, like, what carbon data does this have? It's automatically there on the spot when we need it. Okay, so that was a long go around to get back to where we were. We're trying to estimate carbon for a building, but Speckle is how we're doing that with version control. But we like Nicolas's assembly here. It's quite good. We think it fits our needs, so we're going to select it as an assembly. Now we can actually go in and take a comparison of the carbon costs compared to other assemblies. So on the right side, we have a bar joist with a metal deck, and on the left side, we have the lightwood frame that Nick has created. Just looking immediately, you can see how much the steel rebar on the right, we have 0.8% of that volume of that assembly is making up 41% of its carbon. So that's, that's a large amount of carbon. In fact, the steel on the right side is more carbon than exists on the left side of the assembly, or like the left assembly. So we hope that this when we come through all of this and we build these assemblies and users can pick the ones they want based on their requirements, we hope they can come to this table and they can see, wow, like it's a huge difference using a steel deck versus a lightwood frame. And I think we're accomplishing that. So that's kind of what I was here to talk about. Carbon fixtures and Speckle. We're using them together to try and update how development is done. We're hoping these tools will help you, and yeah, cool. Thank you.
Awesome.
Thank you.
Well, I think it should be obvious to everybody that choosing a collective path and some open source tools that we can get right to work on are going to really accelerate all of us. And we have a great chance to talk about this more over lunch, and I hope we can all stick around because after lunch we're going to have our farthest traveling visitor, Jesce Walz, who's come from a collaborative project with EC3, who's our external database, who we're using as an architect at Perkins Will with a real material palette and sensibility. They've begun building tools that we decided we should really understand, align with, and we're really glad to have her here. And then as we talk about the sort of the binational work on this, we can then have everybody together to face our last round of our questions, and then go out to Winter Carnival from there. So we're gonna have lunch right next door. It's all ready for us. We can jump right out there and and then hopefully come back in here in time for the final round. Thanks, everybody. Our next speaker has traveled across the country to be here, and we really appreciate that. She actually got a chance to come to the Rendezvous of Architects last year and was really inspired by the Quebec manufacturing community. But I've been out to visit and seen what's happening on the West Coast as being so allied with us. And also, as you know, we have so much talent here, but we cannot really answer the question of how to handle all the trends in our actual data set. So we've decided that we should not be the expert on how to calculate carbon on wood. We should encourage every one of our manufacturers to actually embrace transparency, and then we should connect to a live and dynamic data set. And about a little bit of background on this as well is that a few years ago, at the start of this, I looked at other plugins in the space that were doing a good job, and there was a small software product called Tally on the East Coast, designed by an architecture firm whom I knew well, and a great talented team that was really early to the space of plugins for Revit related to lifecycle. And I decided that I would try and orchestrate my team to provide Tally-friendly content, because I knew that whole user community, I knew that whole team, and if we could just publish good product for them to analyze, I knew we'd be in good shape. Since then, Tally really had a struggle and was actually taken on by the large nonprofit team around EC3. So they merged, TallyCat became a thing, and there's a beta software coming out called TallyCat, and the team there also reached out to the Vancouver office of Perkins Will. So why we have a Seattle architect from Perkins Will, we'll let her tell us. But Jesse has actually emerged as a Perkins Will practitioner who didn't really fit their mold, was thinking a lot about materiality and also process. And so she is joined in some ways with the TallyCat team and has really understood a lot about what our whole manufacturing community is up to through her travels. And I'll let her explain her how she blends all these, but we're really glad you're here, and thanks for coming.
Thank you. I'm just going to try to find the clicker. Here we go. Test. Great. Well, first of all, thanks to Eli for convening this group. It's been such an inspiring morning. I know that my brain is full, and it's really crazy to see so many people working on the same problem from different angles. It's a big problem, and I think that we're a lot closer than we were 10, 20 years ago to addressing it, and I'm going to show some examples of how we're closer today, but also I want to acknowledge that what we're working on is one piece and that there's some gaps in continuing to work on interoperability and collaboration, just as people have been since we moved from drafting to CAD into BIM is going to be key. And so I hope to connect more with some of you who are manufacturing, who have presented today about how we can work together. So I'm here to represent the TallyCat tool. We're going to share about why we're building this, what it does, and beyond the beta release. But first I want to introduce where I'm coming from. I'm a part of a team at Perkins Will that includes myself, Alton Jatta, and Manuela Londono. Those are my colleagues from Vancouver. And I became friends with them through data and LCA and make a lot of trips up to Vancouver. And the city of Vancouver has started to require life cycle assessment on several of their projects. So that's a big impetus for people to begin incorporating embodied carbon calculation into their work. And then there's also a lot of timber manufacturing in BC. So we got to talking and connected with some of our other studios. We're a global firm. So, for example, Denmark has also just started including LCA as a requirement on all their projects. So we recognize that globally we actually have to address this problem. And we're also a research firm. Eli said that I didn't fit the mold. That's not totally true. I would say that we encourage breaking the mold. We have overhead that goes into research, and now I'm a part of the firm-wide research team. And I'm leading carbon and circularity and figuring out what that looks like. I just became the leader of that in January. And a part of that path has been collaborating with Building Transparency, which you referred to as a huge organization, but they didn't exist 4 years ago. We had a lunch and learn at our Seattle office, and some people from Carbon Leadership Forum came in and said, hey, we want to build an EPD database. And so Perkins and Will decided we would sign on as pilot partners, and I became involved in that partnership early on, and I've helped the tool to grow and provide feedback. This is the board, Stacy Smedley and Phil Northcott, the developer, really, really, really great colleagues. And they have all these supporters. Now they are a huge organization, but they were not before. And they have been leaders, and they really want to be doing work globally, so we're trying to help them do that. I understand that there are going to be a lot of different EPD databases, but the rigor that goes into Building Transparency's database to help make things comparable is really strong. I won't even have time to get into that today, but they're awesome. So 2-3 years ago, we found this grant, the Clean BC Building Innovation Fund, and it incentivizes manufacturers and clean products, and we thought, well, this EPD database could really incentivize more clean manufacturing in British Columbia, and we want to get environmental product declarations, EPDs, into the hands of designers, not in construction documentation, not in specs, but really early on, so they can start making more informed comparisons based on what's available in the market. And we pitched a tool to Clean BC. That slide is out of order, so we'll skip it. And we got all of this support, which was great. Tons of people signed on, and they said, yeah, we think that there's a need for this tool. It's different than what Tally does. Tally is a life cycle assessment tool that's based on average data. The Tally Climate Action Tool, or Tally CAT affectionately called, will be based on Building Transparency's new database that they're building, and it will be more directly integrated with the EC3 tool, which stands for Embodied Carbon and Construction Calculator. So there's this synergy that happened. Building Transparency didn't quite have Tally yet. They hadn't acquired it, but then we won the grant, and then they acquired Tally, and so it's kind of like evolving what the relationship looks like. They'll continue to maintain this life cycle assessment tool that's very popular in North America and globally, but in the meantime, we're building a new tool. And I just updated my slide deck during lunch because I had this section about why are we building this, and I think, you know, we've talked about environmental product declarations and why they're important. We all know that we have a mandate due to climate change to start acting now or yesterday or 10 years ago. And we all know that embodied carbon is a big contributor alongside operational carbon. And so one thing that we don't totally know, though, is really what percentage of the industry do we have potential to impact? I don't know if, like, you've seen a greenhouse gas emissions pie. These emissions come from here, those come from there, and you can cut it up differently. And I think it's a little bit more clear that building operations could account for 28% of global emissions. But when we start to talk about industry, it's not just concrete and steel that go into buildings. It's concrete and steel as industrial forces. So if I get an environmental product declaration in Seattle for a lower carbon concrete, and then the Seattle airport incorporates that lower carbon concrete into their projects, it's not just buildings anymore that we're impacting. So when we source materials, it's really about the whole supply chain. And for me as a designer, I feel a lot of power in that I'm not just modeling a block in Revit, I'm thinking about an ecological resource, and I'm thinking about manufacturers and connections and supporting change where this one small thing can impact change, not just in my project, but across the whole industry. So that's really driving our partnership here. And then additionally, we're not just talking about extraction or forest carbon, we're also talking about energy. Like I visited a plant with Eli, and they're switching their forklifts to run on electric, or many of the timber manufacturers are burning scrap wood to heat a space. And so then operational carbon and embodied carbon are connected. So as many of you know, if aluminum is produced in a cleaner location, cleaner energy like it is here, then the aluminum is related to the energy source that supplies it. So we're talking about operational and embodied carbon reduction kind of at the same time, sometimes when we procure a cleaner product. This is a screenshot from the EC3 tool where when we build out a project, we can look also at the building operations and the embodied carbon impacts. So embodied carbon in construction calculator and TallyCat look at a subset right now of the life cycle stages. One thing that we face as a challenge, a gap within assessing timber is that first, where do we measure the carbon stored in timber? And then secondly, what do we assume in this like D beyond the life cycle? And Tally right now, the underlying data from CORIM assumes that a bunch of that timber is going to be burned. And so if I include module D in my study, there's an emission and I'm penalized for using timber where I could be planning with the building owner for end of life of that. That's a huge assumption. And so we do hope that our tool will start to get into picking smarter parameters and acknowledging even if timber is landfilled, so much of that carbon is stored in the landfill according to EPA data. So we have a lot to learn about the life cycle of biogenic materials. This tool did start by focusing on product stage impacts, so it's not getting into that just yet. And that is because when we run a life cycle assessment, one, product stage impacts happen before the building opens its doors, so that's a lot. And two, they often take up, for traditional materials, the largest amount. Like people will think that transportation is a big deal, but for a higher intensity product, it's really before the product leaves the gate of the manufacturer. So that was the initial focus of building transparency in the EC3 tool. We've already seen the nutrition label comparison. But what we're seeing now, as somebody else pointed out a little bit ago, I've seen 50,000 concrete EPDs. Last time I checked before this screenshot, which was today, it was 70,000. This is this morning, 127,639 EPDs for concrete mixes. And that is because that industry has made it very easy for its suppliers to make an environmental product declaration for each mix. It's also because one plant might have a whole bunch of different mixes, so it's not like, it's different. It's not apples to apples to compare it to wood products, but I do feel that there is some, there are obstacles, one, but then also that industry recognizes that they have a threat, and so they've come together and they've done the work to make it easy. And so that's something to think about. I think it's a bigger problem that we can address today, but it's cool that people are looking at it, and we're definitely interested in supporting the conversation. This is uptake of EC3 users. I'm just wanting to share that the tool has become pretty big. I think this is last November, so there are probably more than 30,000 users of the tool now. And there's also different ways to import projects in the tool. I could manually import takeoffs, I could export from Tally, and now we can use TallyCat as well. And again, the point of what we're building with TallyCat, which I'm going to show a few demo slides of in just a minute, is to bring it earlier into the design process. So when we started partnering with EC3, the thought was that you would use it for procurement. It was built with contractors in mind. Skanska and Microsoft helped to seed the idea. But as a designer, I want to understand that there's a huge variability within each product category much earlier in the process. So, and also I don't want to repeat my work over and over again, like putting in takeoffs here and then there and then importing and then translating. I would like a more seamless workflow. So those are some of the goals of the tool. And then another goal of really building transparency, which we cannot take credit for, is development of a full open access lifecycle inventory database. And so they're doing that, and they have funding now and are partnering with people in Europe. So hopefully over the course of the next year or two, there will be a full lifecycle assessment database available for free that does not hide behind a paywall, and that also has transparent data that anybody can draw from. So TallyCat will evolve and grow as Building Transparency's database evolves and grows. This is a demo of the tool coming up here, just some screenshots, but the idea is that there's a growing database of EPDs. You can find and compare materials, and you can build out an entire building project, and then you can see your impacts based on the variability within each category of EPDs. And so TallyCat will plug into all of those things, but it also will involve direct export from Revit, and then you can begin to work between the Revit model and your EC3 project to evaluate live as you go, identify hotspots, generate visualizations, and talk with the client team and the consultant team. And just really simply, you sign into the tool. This is available on Autodesk. It's also available on Building Transparency's website. The beta version is available today. And then you set up a project. You create a new view. And it can't assess everything in Revit yet, but what the tool will do is it'll hide anything that it can't assess. And so it makes a view that shows you this is what's going to export. What you see will export into your project. So if a team just wanted to assess a floor slab, they could hide everything else and just export the floor slab. And this is showing the visibility. It's working within, as much as possible, Revit's native menus so that we're not duplicating work. You can use the visibility options there. And then it exports over, it saves data with the Revit model and offers the opportunity to open a web view, which is essentially the EC3 tool side by side with Revit. So it's interesting because TallyCat doesn't necessarily right now have a separate interface. The developer really wanted to make EC3 better as we built TallyCat, so it's serving as a go-between right now. We do have dedicated functionality within Revit that won't be a part of EC3 that we're building out now as we get past the beta stage. But then for those of you that haven't seen the EC3 tool, this could be manually input by a contractor in what iteration, but if you're using TallyCat, it's exported from Revit and it creates an entry for every family, and it makes a guess based on the name and the type of that family, saying, well, this is a floor, I can put it under floors, and this looks like a concrete topping slab, so I'm going to assume that it's concrete, and it will make certain assumptions that the team then has to verify and to get quantities. And then we can take those quantities times the impacts in material in EC3's material database and start to understand carbon data through that simple export process. There's still quite a bit of verifying required. Like if I use Tally, every single Revit family, I go in and I say, this is gypsum, this is insulation, these are studs. And so we have the ability to do that with this tool. However, you can also get a quick glimpse with one click just to get an idea of what's happening. And if somebody has modeled in a really clean way, then that glimpse is more accurate. And then there will be ability in the future to go back and forth and sync between changes that are made in EC3 and made in the Revit model, so that if I build a wall that's somehow inaccurate and I want to add insulation to it, I might be able to send that, adjust it in EC3 and send it back to Revit. So we're working at interoperability. And then this is just purely a screenshot from the EC3 tool, but you get performance information, and then you can put in location. You could filter the range of environmental product declarations by location. Like if I just wanted Quebec EPDs, I could do that. And that was part of the Clean BC incentive, is if I really wanted to look at clean products from one region, I could do that. If I want to look globally, I could also do that. And then it shows you a range of possible impacts, and this is comparing. A really powerful thing here is it starts to compare between manufacturers, so I can see what a baseline is, and then I can see where manufacturers' products fall within that baseline, and I could start targeting in my spec specific products that one might have less impact than another. And these are all concrete, so apologies for that. But, and this is another example here, and they all have uncertainty built into them. So if a declaration comes from a specific product and a specific location, and we know the energy source going into that plant, then it is more certain that we know this is roughly the GWP, the global warming potential of that product. If there's a plant that has 20 plants throughout North America and Mexico, and they've averaged all their data, then more uncertainty is applied, and there might be a little bit higher of a global warming potential assigned to that product so that it can be comparable. And then everything has been aligned to the same functional unit. So if one product has measured something in a different unit than another, they'll align them so that I can compare them in the database. So this is all material mapping, and it's really geared towards, there's that initial step of what is my carbon impact, and then there's this second step of refining to reduce that impact. This is a new feature of the tool, is that there are builders, and so I could build out a slab, I could build out a partition wall, and based on the data that I put in here, the tool will do some math, and it will give me material quantities for things that are not modeled. So like studs, we don't typically model wall studs, but it'll interpolate those and take the gauge or the dimensions of the stud and come up with a material quantity. So there's something that isn't modeled. Do I really need to model it, or could I just do the background math and tell this tool what it's made out of? I'm going to keep scooting through this, but you can select materials in Revit, You can check out summary and reports. The Sankey diagram is the name for this flowy diagram that EC3 is really well known for. And here, the little zigzags, those represent variability within a product category. So here I can see, and frequently show this to clients, 53% potential reduction if I specify within the 20% lowest GWP products available. And so it's not even the best, it's just if I aim for the 20% lowest within the search range, and then you can trace that back and say, okay, what were the primary contributors to that? And look, and then you can go into the tool and find those line items and say, okay, well, I gotta pay attention to my glass. Timber usually shows up as a really small one because it's already pretty small, but if I really wanted to compare timber products, I could isolate the timber structural members, and then it would still show me the variability. I'm gonna keep scooting through this because I just explained that. And then you can do lead reports. There are several, lead in the US is a big incentive to doing this. There's several different credits that relate to life cycle assessment and use of EPDs. And you can also explore hotspots. This crazy beehive was an early test building that they were playing with, but the tool will highlight things in Revit that have higher or lower carbon impact. This slide is from Phil Northcott, the developer. Since the tool was released, it was developed for, initially inspired by this Microsoft campus project that required environmental product declarations. The average GWP of 5,000 PSI ready mix concretes, this is just one example, but it has reduced in the tool, so a larger quantity of low carbon concretes have come to market, and they're able to track that since the tool was developed and since demand for these products came into play. But we're here also to talk about timber, so I wanted to share another project and how we used this tool on a mass timber project up in Western Washington. And our firm has developed something called the carbon forecast that we're experimenting with, and that aligns with this World GBC path to carbon reduction that really starts with reuse and then looking at carbon storing materials and optimization, and then something like reducing the cement in your concrete mix would come later. While that will apply to all of our projects, and we certainly want to have the impact that can be achieved there, we also want to rethink how we're working. So we can't dig out of a hole by digging the hole more slowly. If I want out of the hole, I need to think differently. And so that's the idea around reuse and thinking more about biological materials. This is the carbon forecast main splash page for this project, and we compared it to a code minimum building, and then a typical early design for Perkins Will for this client might have had a 17% carbon reduction, but then we were able to transition this project off of its steam grid and onto electricity, and then have solar and also green power purchase, and then a mass timber building. So I'm just gonna look at the embodied carbon breakdown approach for this project. The first early design stage here represents an initial reduction, and then we looked at reuse and low carbon and circular material types, quantity optimization, and then product and specification strategies. And so to do all those things, we had a tally model where we did build out a concrete and a timber model and compared them to an early level, and then we actually looked at like furniture and other things that could be reused for the project. And specifically, the carbon storing materials, this was something that was a huge incentive for the client. And they really want to know for their students, how can we justify this? Because there's controversy everywhere about timber. Is it really sustainable? Is it not? And so we are working with Kolesnikov to procure the timber, and are hoping to use some of QWEB's tools eventually to do a study and see how our tally timber analysis would relate to one that has more manufacturer-specific inputs. And then another thing that is more specific to TallyCat and EC3 is that, if we were to compare, even in early design, different options, this is just for the structural deck. So there's a delta beam, timber over steel, steel frame composite, and post-tension. And you can break it down by all the materials that go into each of these. We don't have a pure mass timber one in this slide, but this is just for comparison to show you. And then the thing that we can do with TallyCat or EC3 is that it's not just a solid number, what is the impact of each of these materials, but each one of them has variability, just like in that Sankey diagram. And so I can start to see oh, if I really reduce the carbon in one of these products, it might actually bring my range down, or if I had to select higher carbon products because I was VEing and trying to get the cheapest procurement or whatever, then it might have a higher impact. So just understanding that all the design decisions make an impact. I think where this comes in with wood is really that the full timber option, if we can validate the data with environmental product declarations, is going to be lower and the variability is going to be very small. So it's kind of like, this is just the right decision and we want to reinforce that, but we also have to be able to do it with data. And then this is the breakdown of one of those projects. So you can see per item, there is the material, and then there's the quantity, and then there's the collection, which I can filter that collection by location or by other properties and try to look for products that I would want to specify. We are working on a material library and several other features that are going to come out in the full release, and we're targeting kind of like a mini release in April on Earth Day, and then I think that we're going to have an event at Green Build this year. So similar to EC3, when they released the tool, they just kept including updates, and they continue to. And so this tool will be the same, where we're going to continue adding things to it. Tally will continue to be supported until there's no longer a need for it. Right now, people like Tally, and so it'll be there, but it won't necessarily evolve. Whereas TallyCat will keep evolving. And then we're aiming for more advanced quantity takeoffs, like a better curtain wall tool, more ability to map materials between the model and the EC3 tool. We're working on a report feature with Magnus and Klemenkik, which is a structural firm, on just some visualization and reports that will be easy to share with clients. And then a content library and ways for firms to save information that they would want to that has carbon data annotated to it already, which is where I'm very curious about what some of the other tool developers are doing here. If there's an annotation of carbon impacts with a family, is there any way for that to be interoperable, and how are we each doing that? So this is Scan Me. You might not be able to scan from there, but on buildingtransparency.org's website, you can just click on TallyCat and download the tool at this point if you want to. And yeah, I'm glad to take questions or chat. But I think, I don't know, I just want to emphasize two things. One, there's a huge power for industry transformation with data. And also what we are seeing is that some of the leaders of that are the ones that have the most to lose, because their products are going to take a lot longer to clean up. And there's a lot of kind of like whataboutism. I just contributed to a building code proposal for Seattle where we wanted to require global warming potential thresholds for steel and concrete. And those industries were saying, we won't do it unless you also do for wood. Wood is saying, well, we're not going to participate because our product's already clean. And in our region, at least, it's very challenging. So it's really encouraging to see this conversation taking place, because it's kind of like each separate group, we all need to figure out how to make sure that we can demonstrate that we're participating in a regenerative way towards the future that we all want. And we can't get caught up in this kind of like, what about this, what about that? Because then everybody's just going to say, oh, I can specify lower carbon concrete. I'm going to keep using concrete. So I'm really hoping to see more biogenic materials in our projects and to be an advocate for that. So thanks for your contributions.
That was awesome. Thanks so much, Jesse. I want to hear some questions for Jesse. Sylvain.
My first question is, what do you think about, because we are working with Eli with our stuff with EC3, but what's your feeling about all the existing software and system, closed box with LCA evaluation, that there's regional or national, there's a lot everywhere, Athena, whatever. What will happen with those closed box stuff? They will all die, I think? What's your feeling about it? Because now it's a nightmare. There's a lot of stuff closed that want to survive.
For sure, yeah. Athena is actually making a web version of their tool. They're working very hard to, stay relevant. I think that's kind of like we should ask a life cycle assessment expert. But I'm actually taking a course at BCIT with Athena just because I want to understand better their perspective. And I don't know. I think like EC3 tool is doing things, they're breaking the rules a little bit. There isn't necessarily like an ISO approved way to use environmental product declarations for LCA. And so right now we're calling this a carbon assessment. And there will be still Tally, which is maybe more closed box and applies to these other rules. I think over the coming year, as Building Transparency develops this open access database, and they have a lot of methodology experts working on it, they're going to have to continue engaging with some of these other organizations and understand how much, is it, I think there's a perceived risk in comparing two things that might not necessarily be perfectly comparable, but there's also a huge risk in not acknowledging that there's a variety of impact for each material category on the market, and I'm more concerned about that risk personally.
Do we have, Mark?
Yes, you had that slide where you were showing your steps to reduce carbon in the early design and going on. And from a baseline case, and you directly jumped to 35% on your first early design, and then I saw circularity and stuff like that, where, like for example, I'm trying to develop like circularity with manufacturers for steel, for concrete.
Yeah.
And that's very regional, understand? How do you tackle that? How do you, because you're prolonging the life cycle or the life expectancy of the material,
Mm-hmm.
and then is that something that you can measure through TallyCast, like the circularity?
Yeah, well, right now we don't incorporate module D, which is end of life. If I, and so there's multiple things there. One is recycling, can this thing be recycled? And the other one is lifespan. Okay. And I personally, I feel like this is a huge obstacle. How do we agree on how to measure that? Where do you attribute the value of the recycling? And my understanding, somebody correct me if I'm wrong, is that some people attribute it in different ways. But I feel like it has to be, for me and for our firm right now, it's that there's this underlying foundational way of working where we say circularity is important. We might measure a building's impacts over 60 years, but there's a huge loss if it doesn't last for longer than that. And so one way that we address that is by, instead of starting with right now, how many new products am I going to procure, also looking at what's on site. So if I could start with reuse, then that's the circularity I have control over now. And we can plan with the client or look at design for disassembly or talk to manufacturers about circularity that might happen in 60 years. But taking accountability for what we can start with now is it's like the most tangible thing.
Because what I'm seeing is that there's an impact if you can tackle the life expectancy of materials, and you start to say, well, there's a value to that, to trace.
Yeah.
Trace so you can actually consider, we call it the material banks. You consider building as a material
Absolutely.
bank.
Yes, definitely.
Have the material passport, and then and that expands into a numerical system. But does that really, because they're starting to put value on those passports and saying, well, there's CO2 value, there's economic value, there's different values around.
Yeah, we need that. Well, our firm is addressing that. We've signed the AIA Materials Pledge, which is like different categories of value, and including equity and materials health and other things alongside environment. So that's one thing, and tracking them is very hard. I don't think that we have a standardized materials passport yet, and a lot of people are trying to crack that nut. And like when somebody was saying there's 10,000 SKUs because of like different colors of paint and everything, and they don't all line up. So that's something that we're very interested in, and I think it's an industry-wide issue. And then our London studio has this great Net Zero Now pledge where they're looking at materials and buildings as banks of value. Within LCA, the closest assessment I've personally done to that is looking with a client who is going to replace their interior finishes once every 5 years with a fit out. And if you run a life cycle assessment and assume those replacement cycles are happening every 5 years, or if you look at a curtain wall and hey, this might have to be replaced in 40, but then maybe the timber one, its seals don't break and it has a longer lifespan. So you could pick a span of time and then demonstrate that those stage B use replacement cycles would be fewer and your impact would be much lower if you keep things for longer. But Tally EC3 doesn't quite do that yet, but it's on the radar.
Question, value of a carbon saving at year 1 versus an expected carbon saving during operation, or even at the end of life, 60 years later. So like money, do you put the difference between the ton of carbon saving at the construction versus the expected ton of carbon saving 60 years later because of reuse? Is it the same value in terms of carbon?
Is this a rhetorical question? I agree. I think there's so much between economics and carbon that we're missing at. Like timber, the value of the carbon stored in it could be treated as a bond. You know, there's a lot of different ways that we should be looking at things. That is why we're focused very much on upfront carbon impacts, and so then reuse or a circular or biogenic material, biological material. That's savings right up front, as is reducing manufacturer impacts. But we don't.
But there's nothing done yet about the value of the ton of carbon versus.
I know there are studies on it,
well,
but I don't.
Well, it sort of sounds like homework that my Ageco guys gave me recently.
I do think
sounds like,
someone else might have input.
This sounds like a dynamic LCA that I'm supposed to understand, but I'm going to actually throw that question back to you.
Yeah, thanks.
The IPCC panels on a world level, they like this. It's called the dynamic approach for the LCA. So, like when you calculate the global warming potential of a gas that you emit in the atmosphere, and it's mostly on a 100 years basis. What is the impact on the atmosphere over a 100 year span? And when you take into consideration the dynamic approach, it's like when you emit a gas at year 0 or year 60, like the area under the curve of your impacts on the atmosphere and climate change is not the same. So considering if you emit at 0 or 60 after 60 years, it's not a linear equation anymore. And so like dynamic approach is not commonly used at the moment, but for timber it makes a lot of sense because it's actually storage of carbon that is re-emitted 60 years ago. But the theory behind, just in a sentence, is it's better to emit carbon in 60 years than now. This is like the theory behind dynamic approach. We just save ourselves 60 years if we don't emit the carbon at the moment by using timber instead of steel. And we might not have a consensus about how to model the dynamic approach, but at least we save ourselves 60 years. That's the theory 101 behind dynamic approach.
Also, we're saving the uncertainty.
Yeah.
What's going to happen in 60 years? We don't know, but what happens now?
Yeah, it's the same thing with the energy. When in Europe there were energy regulations, you put the performance energy, but during operation, this carbon was not approved by the IPCC because it's a maybe saving. Because if the people live in a passive house and sleep with the windows open, there will be no saving. So it's not a real saving. It's an expected saving, not approved for accounting at the national level.
I feel like that's something that we could build into a visualization with a tool, is to say each stage of your impacts, you could choose to have a graph that would weight them differently based on a different model if you wanted to. We can't control the standards, but we can control how we provide information and use data to illustrate a story.
There was also, oh, go ahead, Tim.
Go ahead. No. It's a different question. So if you're
well, I'll just finish what we're saying here about reporting out of data, how to handle data, are all things that need to happen. But for our teams to meet once was really cool when we saw, actually, for a moment here, we're feeding reliable quantity calculations towards people who are working on those. So at that moment, I think we both felt like, all right, there's a way that industry expertise and like in Revit content can help flow towards those. And I think we went into this thinking somehow we have to figure out a way for our two provincially funded things to work together. Somehow we want to work on a similar goal without duplicating effort. And at that moment, we were kind of like watching both of our teams be like, oh, that's really cool what that can do, was kind of a signal that we're on the right track. So while you guys figure out all the dynamic stuff, we're going to stick on quantities and defensibility and
transparency.
Yeah, absolutely. Yeah, and having open source partners means we were able to plug right into their database and get going. So that's saved us probably 60 years right there. Tim.
Yeah, so my question is much more snapping back to the international architectural firm that you have and your work in it and how it actually is prototypical or deployed or intended to be deployed across the offices, and if you could speak to how Perkins and Will actually uses it. So you provided one case study and an LCA that case study and the use of TallyCAD or EC3 in that case study. But if you could speak a little bit, step back and speak a little bit more globally about how Perkins and Will uses it in total, as a percentage of projects or as a commitment to a particular region because the data is accurate in the Northwest, for example. I don't know.
Yeah. Totally. So our process has evolved. When we first partnered with EC3, we formed an embodied carbon working group, and it was people who were interested. A lot of them came from our materials health section, which was interesting because they were already thinking about specs and procurement. And that group has grown to where we have representation from almost every studio. I think Shanghai we're still working on, in Sao Paulo, but so that's grown, and we're working to empower local leaders. We have a bunch of firm-wide trainings, and we've trained in the EC3 tool. We train in Tally. I tell people I can teach anybody Tally in like 15 to 20 minutes because it's so easy. But then once you get into EC3, it's a little bit more because you learn about life cycle assessment and environmental product declarations as you start using the tools. Some of our studios have sustainability teams. Other ones are teaching their architecture teams to do the work. And as an architect, I feel like the easiest thing is to have somebody on the architecture teams using our tools. We committed last year to this thing called the carbon forecast. And so what I was showing you was this approach where we want to encourage reuse, use of carbon storing materials, and procurement reduction, as well as within operational electrification and optimization and such. And so we're currently, I'm just coming back from a retreat where we're building a really early design tool to help teams understand hotspots that they would not get at in later design. Like some of those things I just mentioned, if you're in design development about to run an LCA, you're not going to decide then to like reuse the building or switch to mass timber. So we are working on a really early design tool that we will expect every project team to use.
Internally, though.
Internally. Yeah, I'm not sure what will happen with it yet. I mean, I think that there's a lot of value in contributing to open access tools. So TBD on that, but we need to test it and vet it because it's easy to just take flack when you release something that's controversial out into the world. And yeah, then our studios are all a little bit different. So some have committed to life cycle assessment on every project. Some that do more interiors work are more focused on improving their interiors. But where we can have a uniform approach, we will. And I think it's about building literacy and identifying biggest opportunities for reduction.
So last, kind of tack on question. In the next 3 or 4 or 5 years, you could imagine LCA on every project. Not a promise, but
yeah.
Sort of a vision of.
I don't totally know. I feel like there's different opinions about whether we need to run life cycle assessment on every project. Like we need better benchmarks, and we need to know that we're reducing our carbon and be able to quantify that somehow. And then I think the value of life cycle assessment is have you really done a refined study and done your homework, and then being able to contribute to benchmarks, like I said, and then looking at other impact categories. Yeah. So possibly,
You don't have to run it again for a similar project.
Possibly not. So, I mean, it just depends. I think it depends on the client and the certification. I do think carbon assessment for every project will be important. And then there's other things. We have this whole living design framework, so health and equity and regeneration and thinking about biodiversity. So life cycle assessment is one way to get into a bigger system of thinking, which is something I'm excited about. And I would love if every project team did it. But I guess as tools are evolving, we'll kind of have to see what makes the most sense.
I had a question from Mo.
Yeah, thank you, Eli. Thank you. It's kind of really interesting presentation and the tool itself. I'm just going to go back to Sylvain's earlier comment about the tools. I just want to share with you what is happening here at the national level in Canada. There is a major project. It's called the Low Carbon Assets Through Life Cycle Assessment, or LCA Square. And it started a couple of years ago, and NRC is actually led by the National Research Council in Canada. And the industry, basically all industries are involved, in addition to provinces and federal governments here. PSPC, for example, Public Work is part of that. And the idea is really focused, because a tool is a tool at the end. It's really about the core, which is the EPDs and the data that is being used, and how standardized the approach, as you pointed out, that's used to develop all those EPDs and the data for each individual material. So part of the goals there is to develop a national Canadian database for all LCI, like life cycle inventory, data for all construction materials in Canada. So they have been inviting all the material manufacturers to provide basically their data, and I think they are finishing up now, with the wood, basically. So I think that might be a way of going to Sylvain's earlier comment about having maybe a standardized database, and maybe that would lead to maybe a major national tool, or even if you have several tools, that's not bad, but it's the data that really matters at the end, the way I see it. And I'm not an expert in the area, but I just think that's really about the database at the end of the day. What kind of assumptions, what kind of procedure and the assumptions made to develop the EPDs and everything else. Anyway, I just thought I'll share this with you. I don't know if there are similar efforts in the U.S. happening or not.
Probably mostly probably the EC3.
Yeah, most likely, and they're collaborating with Ramboll out of Europe and some others. So it would be interesting to see if there's an opportunity, especially as some of the later life cycle stages get built out that are not manufacturer specific. It would be really interesting to see if there's opportunity. I'm sure that Stacey Smedley, who's the executive director of Building Transparency, is probably aware, but it would be good to nudge her, make a connection, have a call. Yeah, that's awesome. Thank you.
So we also wanted to equally put the rest of our team in the hot seat here. I was even going to bring everybody up to the front. I don't know if that's necessary or not, but I want to make sure if people have questions for other teammates besides Jesse and I, let us know.
What amazed me the most about all this stuff is that you, the end user, chose to decide you wanted to change your main industry, and you reinvested your own money in it, put the works in it, and with your business culture, you can make the industry move forward, which is really amazing. And as a business, be a good citizen for today and for tomorrow. I was just wondering if you have any advice or maybe just insight on how to foster those initiatives, or how to gather people around like you did to become not competitors but co-opetitors as they work together toward the main goal.
Thank you. That's nicely said. And it's really a privilege to be working with a lot of others who are like that. I feel like community and openness fosters more of itself. So that's one way to work. I think, like you mentioned, humility a lot when you were talking, recognizing that the problem is bigger than us, and that we also we cannot be responsible for solving it. So seeing that others with expertise and backing had the ability to engage, and then seeing the value in being one contributor. But also we all, like all ships, must rise. And so I'm not a huge believer in proprietary tools. I think open access data and something that anybody can use is really important. We have a history of collaborating as a firm doing stuff like that, but it was really compelling just to see what Building Transparency is doing, and that it was bigger than what we could do. And then also like the Embodied Carbon Working Group that I mentioned, having just times for different people to come and share. Some of my colleagues are amazing collaborators, and when there's a speaking opportunity, they'll share it or pass it on, or when they see someone doing something, they'll highlight them. So just building a grassroots movement where people who are making the little decisions that add up to bigger decisions can feel like there's meaning and value in that is important.
The other thing I think that's been striking for me to have a chance to work outside of Quebec. First, in Quebec, there's this incredible talent pool and understanding, but it often doesn't look very far beyond itself, doesn't look completely into the U.S. to what's going on, or then we find ourselves looking at what's going on in the West and the East and finding commonalities. And it's a lot easier to help your colleagues change when you have like that. I don't want to call it peer pressure, but like, you know, we could wait to adopt a lot of this stuff in Quebec, but if BC's going to do it, actually everybody's like, well, wait a minute, okay, maybe I will jump to this, or even if my local competitor is going to do that, or I mean, I had an awkward conversation in America with the AWC when I had to tell them like we're working on transparency, and at that point they were going to lobby to block it. And I was like, well, I don't think that's a great look. We got some regional trade associations that are going to move forward. And one of the things that we heard was like, well, and then I laid down a little bit of a veiled thread of, you know, there's a lot of binational ownership. There's a lot of people, there's sawmill owners who might embrace transparency in any of our groups. And somebody said, well, what if somebody gets paid more for their sustainability and transparency efforts? And I just let that sit for a minute. I'm really glad we're having this talk. Like, yeah, maybe there might be a market premium for some of this. And then everybody actually was like, oh yeah, like actually that competition factor, if we can share the data and if people will pay for it, or if we don't get lost in a third party rating system and we're actually rewarding people who are taking steps, then I think competition can make things move really fast.
Yeah. Another issue is the policy, and that's where the problem is, because the industry will do nothing if there's no threat. In Europe, when they force EPD by January 22, all products need to have their EPD, because there's a regulations on the performance for energy and carbon by this year. So
I don't know if that's going to work in America, though.
Anything like that in North America, but we start to see like California, by Clean Act, New York, putting carbon mandatory as a procurement with EC3. Then the industry wakes up because.
There is a federal. North America or the U.S. is starting a federal investigation into requiring environmental product declarations for steel, concrete, glass, and I think insulation. I don't know if it'll go. Hopefully, it flies under the radar enough that it doesn't get.
And the problem when there's a procurement policy, it cannot go to a closed box that you have to pay for it.
Mm-hmm. Yeah.
Because then it's private. So change everything.
I have a question for whoever might know. Is anybody here working on efforts to evaluate forestry practices and how those come into play for accounting for the carbon stored in a timber product? I'm working with a group that's looking at that, but they're not like an LCA group. There's forestry.
Yeah, there's a group in Canada working on it with at the IPCC level, also at the UN level. The accounting, the harvested wood product. The global stuff is the accounting of carbon in forest and carbon in products at the end of life, and the accounting of that, like LULUCF rules. In Kyoto, they didn't agree because they didn't agree at all, so the forest was excluded from the calculation of national countries. The only thing that was accepted was forestation and deforestation. So if you have a forest, you cut, you make a building, then you have a penalty or a low carbon. If you have a crop somewhere and you put new forest, then you have a plus. Now they try to find a way to include the biomass or the carbon increase in existing forest and the carbon in products. But then there's 5 people in the world who understand the full links of the complication about that. So at the end, we didn't agree. But everybody knows it's true. But how you put that into a national accounting policy for a country? Very complicated interpretation of natural forest, degradation, and we see now rules in Europe that are foolish, like degradation. If you go in the forest where nobody have gone, it's a degradation. You kill everybody. It's very complicated. Plus, you have to add disturbance.
Yes. Yeah.
Country didn't cut any of their forest. We'll have the carbon, and there's a fire. And no more trees. Then your national accounting that year, it will cost you $10 billion of carbon, and it's not your fault. So nobody agreed to put forests in their accounting because there's too risky. So it's very complicated.
Yeah, that makes sense.
We better keep industry like building sector with the easy stuff to understand and kill. Forest will be a long story.
I'm going to pitch a competitor firm, ZGF, has developed a tool called Upstream where they're looking into forestry impacts, and also both they and we are working with EcoTrust in the US to produce a study that's about forestry and carbon. I don't know that it will connect directly into LCA data, but just trying to understand alternative paths to certification being the only path.
You have Werner Kurtz in Vancouver that can explain you.
I suggest there's a group within Canadian Forest Service, which I work for.
Awesome.
Some of my colleagues, Werner is the expert on this.
He's the lead author of the forest chapter at the IPCC.
I'll be happy to connect you with him and his team. He has like a team also working, Carlin and others. So I'll be happy to connect you with them.
Thanks. Awesome. I feel awkward standing up here with the
I know,
microphone when there's so many
I was
other
gonna
people
make,
who
I was
could,
going to
like,
make my whole team come up
can I
here,
take
but
them?
yeah, why doesn't everybody come up here? There must be, we'll pull one more question out of somebody just by having you all up here, and if not, then we'll say thanks to everybody. So everybody who spoke today, come on up here.
Thank you all.
You don't get to run off, though. So I guess if I'd like to hear if there's any more questions, how we all connect, because we've had a chance to work really through the pandemic in a chain-like fashion, assembly line-like fashion, and we've all really enjoyed getting to be a part of this project, but it's only now we're starting to see that we could actually bring a broader impact. Super interested in hearing from our U.S. friends too, how we think this might be able to keep on going for you guys. We all, actually Jesse and I both look at funding gaps and how to fill those and how to find ways to keep teams going. So we're all going to try to keep comparing notes about how to keep on going with this project. But I think for me, the take home is if we build it open source and we build good infrastructure, there's a chance that other people might tag in and these tools may take on a life of their own. But I'd be happy to hear more questions for any of these guys and put them on the hot seat. You're lucky. I'm going to go sit in the audience and ask you guys questions.
Well, it seems like it's a
Well, because you come from a progressive municipality that takes the highest percentage of our region's exports, it's really obvious how we could actually a little bit of policy, or if our tools were actually available to policymakers, or if developers in your area got a tax credit for doing something carbon positive, and we all lined up with data, then I think the passive house community has already proven what can happen when tax credit scorecard changes. In the U.S., it's not all about mandates. It's about, can I invest large tax money into a project that wouldn't pencil out otherwise?
So they get an increase in density or unit count or something.
Right.
Like that.
So anything that we can do to get private sector trade-offs and then bring actual products from
our level of that is, I think that's a plus, and I think about, you know, San Francisco and the Northwest. I think about, you know, there's a bunch of ways in which having a sending region and a receiving region in the policy can work. But we're not really policy tool builders. We're just building the infrastructure for that. So.
Well, I think that's why it's important, because it's rather than a municipality saying, well, you have to use these 10 products, it's a much more intelligent way of approaching it. So it works.
I was struck by the design for manufacture component. It's less on the embodied carbon. It will help reduce carbon in long form, but as a practicing architect, thinking about the collapsing or the making efficient of the building model, the building information, the manufacturer who is able to use both and help work early on with the team to create the solutions that we need. It seems like your team is sort of setting up a sea change in the typical design, bid, build. It'll work with design, bid, build, but you're setting up a sea change in terms of how architects, developers, owners, and manufacturers work together from the beginning. And I'm trying to imagine once that happens, like once that I'm just like, what's the next step from there? Or what does that look like, and how does that actually get defined? And those efficiencies of more intense upfront collaboration, how are those defined? How do those reduce our carbon emissions? It's sort of a silly question to daydream about, but I'm sitting here wondering, you know, what that looks like. So I'm happy to see all the progress and stare at the future.
That sounds like a setup for some social housing initiatives under work here. I don't know if we can talk about it yet, but we are trying to get to where there's an ability for housing needs and housing policy to translate directly to manufacturing capabilities. And yeah, and that should be coming forward more in the next year, 18 months or something like that, and we hope it's relevant for other areas. Natalie's not going to say a word though.
When we talk about maybe it's too ambitious, what you said, it's more to put some architect between the link what the manufacturer can produce, but it's not in the way that to reduce carbon, but we promote wood.
Right.
But it's a first step.
Actually, there's a really easy version of this with these guys who have found that we're all getting together with a manufacturer, and we look across at each other and say, if we can do this together this well, we can turn to the GC and say, do you want to save 4 months, or do you want to do it your way? Go and do your bid, go and do your slow way, keep everybody in a cubicle. We're going to go do this 4 months faster, 3 months faster. So sometimes it's as simple, you know, we're going to collaborate to make this faster or speedier. Maybe it's not all about carbon, but those are all like, I think, real positives about chance to get to work with industry and with architects, because we haven't really, nobody's asked each other, nobody's come to the architects and asked them what they need, and nobody's gone to the manufacturers and said, you know, we should really build what the architects need, because everybody thinks they know what the architects need, but they don't really. So, it's been great to be in the middle of this, and I'm really glad we've gotten to pull so many awesome people into it. So, thanks everybody for coming.